Have you ever seen Cherry Coca-Cola's incredible manufacturing process that happens at an unimaginable scale? Factories produce millions of bottles and cans daily, combining the perfect balance of carbonation's signature cherry flavor with absolute consistency. In this documentary, we take you behind the scenes of the Cherry Coca-Cola production process, revealing the lightning-fast bottling systems that keep this iconic flavor flowing worldwide. The process begins with water, which forms the base of Cherry Coca-Cola. It's not just any water that can be used. It must be highly purified to ensure no off-tastes or impurities interfere with the final product. Upon arrival at the factory, water undergoes a multi-step purification process. First, it is passed through large sand filters to remove visible debris and particulate matter. Next, it moves through activated carbon filters, which strip out chlorine and other organic compounds that could affect the drink's flavor. This step is crucial in ensuring a neutral tasting base. After this, reverse osmosis or microfiltration is employed to remove microscopic contaminants, bacteria, and dissolved minerals. This purified water is continuously tested for pH balance and purity before being approved for use. Now, it's time to introduce the sweeteners, which are responsible for Cherry Coca-Cola's characteristic sweetness. The type of sweetener used depends on the region. In North America, high fructose corn syrup is the primary choice due to its affordability and efficient blending properties. In other regions, sucrose from sugarcane or sugar beets is used. HFCS is produced through an enzymatic conversion process that transforms cornstarch into glucose and then into fructose, creating a highly soluble and sweet liquid. The syrup, or sucrose, is delivered in tanker trucks and stored in large stainless steel silos within the factory. Before use, the sweetener is filtered and preheated to ensure it integrates seamlessly with the rest of the ingredients. The next essential ingredient is phosphoric acid, which gives Cherry Coca-Cola its slight tang and acts as a preservative. Phosphoric acid is sourced from phosphate rock, which is treated with sulfuric acid to produce a food-grade acid that can be used in soft drinks. This ingredient arrives at the factory in concentrated liquid form and is stored in specialized tanks to prevent contamination. Precision is key when adding phosphoric acid. Even a slight variation in concentration can alter the drink's flavor balance, making it too tart or too flat. Caffeine, another critical component, is added to provide the beverage's stimulating effect. The caffeine used in Cherry Coca-Cola is either extracted from coffee beans and tea leaves or synthesized in laboratories to maintain consistency. It arrives in powdered form and must be carefully measured before being dissolved into the syrup mixture. One of the most recognizable aspects of Cherry Coca-Cola is its deep brown color, which is achieved using caramel color. Caramel color is made by heating sugar compounds with acids or alkalis, creating a complex mixture of caramelized sugars that provide both color and subtle bitter notes that complement the drink's sweetness. Caramel color must be carefully controlled for shade consistency, ensuring that every batch of Cherry Coca-Cola has the same appearance. Now, it's time to add the proprietary natural flavors that define Coca-Cola's unmistakable taste. These flavors, known internally as Merchandise 7X, are a carefully guarded secret, containing a mix of citrus oils, spices, and herbal extracts. The precise blend is known only to a handful of people within the Coca-Cola company. These concentrated flavoring agents are added in precise amounts, ensuring the signature cola taste remains identical across all global production sites. But what truly differentiates Cherry Coca-Cola from its classic counterpart is the cherry flavoring. This is created using natural cherry extracts or synthetic cherry compounds, depending on local regulations and supply chain availability. Natural cherry extracts are obtained through cold pressing ripe cherries to capture their essence, while synthetic cherry flavors replicate the fruity, slightly tart taste using chemical compounds such as benzaldehyde. The cherry flavor must be added in a carefully measured amount to create a perfect balance with the cola notes without overpowering them. Once all the ingredients have been sourced, purified, and prepared, it's time for the next step, creating the concentrated syrup. In a dedicated syrup production area of the factory, large stainless steel mixing tanks equipped with powerful agitators are used to blend the ingredients into a homogeneous mixture. The process starts by heating the purified water slightly to improve ingredient solubility. The sweetener, whether HFCS or sucrose, is then gradually introduced while the mixture is stirred continuously to prevent crystallization. Next, the phosphoric acid is added, providing cherry Coca-Cola with its signature tangy undertone. Because phosphoric acid is highly concentrated, automated dosing systems are used to ensure precise measurement, preventing any deviations in taste. Following this, the caffeine is dissolved in a small amount of warm water before being incorporated into the syrup, ensuring even distribution throughout the mixture. The natural flavors, including the merchandise 7X blend and cherry flavoring, are then carefully added. These flavor components are typically pre-mixed into an emulsified solution to ensure they disperse evenly throughout the syrup. This step is crucial, as any inconsistencies in flavor distribution can lead to variations in taste between different production batches. Finally, the caramel color is introduced, giving cherry Coca-Cola its signature appearance. Once all the ingredients are combined, the syrup undergoes a multi-stage filtration process to remove any undissolved particles. This is typically done using fine mesh filters or centrifugal separation methods, ensuring that the syrup is smooth and free from any impurities. After filtration, the syrup is transferred to holding tanks, where it is kept under controlled conditions before being sent to the bottling stage. Throughout the syrup production process, quality control plays a vital role. Factory workers take samples from each batch and conduct tests to measure sweetness levels, acidity, and overall flavor consistency. Sensory panels, trained employees who specialize in taste testing, evaluate the syrup to ensure it matches the established cherry Coca-Cola flavor profile. If any discrepancies are detected, adjustments are made before the syrup is approved for bottling. With the syrup now fully prepared, the next step is dilution, carbonation, and bottling. This is where the concentrated syrup is combined with carbonated water and packaged into cans and bottles for distribution worldwide. But before we get to that, the syrup must first be transported to the filling stations in a highly controlled manner. The next phase of production ensures that the correct syrup-to-water ratio is maintained and that the carbonation process delivers the signature effervescence that makes cherry Coca-Cola such a refreshing drink. Now that the syrup is ready, it's time to move on to the next critical stage, blending the syrup with carbonated water and ensuring that the correct levels of fizziness, taste, and consistency are achieved in every bottle and can. This process is where cherry Coca-Cola transforms from a concentrated mixture into the refreshing, bubbly beverage that millions of consumers enjoy. Now that the concentrated cherry Coca-Cola syrup is fully prepared and stored under controlled conditions, it's time to move on to the next crucial step in the manufacturing process: blending the syrup with carbonated water and ensuring the perfect level of fizziness. This stage is where cherry Coca-Cola takes its final form, transforming from a concentrated mixture into the refreshing, bubbly beverage that millions of people enjoy. The precision involved in this step is critical because even slight inconsistencies in carbonation or syrup dilution can result in an off-tasting product. The process begins with the careful transportation of the concentrated syrup to the filling stations. To prevent contamination and maintain consistency, the syrup is pumped through stainless steel pipes from the storage tanks to a specialized mixing unit known as a proportioner. The proportioner is one of the most vital machines in the entire production line, as it precisely controls the ratio of syrup to water. Cherry Coca-Cola's signature taste depends on the exact balance of ingredients, and any deviation in the syrup to water ratio could result in an overly sweet or weak-tasting beverage. The standard ratio for Coca-Cola products is approximately 1 part syrup to 5 parts carbonated water, but this can vary slightly depending on factors such as temperature and altitude, which can affect carbonation retention. Before the syrup and water are combined, the water must undergo a final round of purification to ensure absolute consistency. Even though the water has already been filtered and purified at the beginning of the process, additional treatment steps are performed just before carbonation. The water is passed through activated carbon filters once more to remove any remaining traces of chlorine or organic matter. Then it is chilled to a precise temperature, usually around 1 to 3 degrees Celsius. Chilling the water at this stage is essential because cold liquid absorbs carbon dioxide more efficiently, which results in finer and longer-lasting bubbles in the final product. Now comes the most intricate step: carbonation. The carbonation process is what gives Cherry Coca-Cola its signature fizz and enhances the overall drinking experience. Carbon dioxide gas is injected into the chilled water under high pressure using specialized carbonation tanks. These tanks are equipped with fine diffusion plates that allow the gas to dissolve evenly into the liquid, ensuring consistent carbonation levels throughout the entire batch. The CO2 used in this process must be of food-grade quality, free from impurities that could alter the beverage's taste. To maintain the ideal carbonation level, the process is carefully controlled using high-precision sensors that monitor temperature, pressure, and CO2 concentration in real time. Once the water is fully carbonated, it is immediately mixed with the concentrated Cherry Coca-Cola syrup inside the proportioner. This must be done swiftly to prevent any loss of carbonation. The high-speed blending process ensures that the syrup and carbonated water mix thoroughly without causing excessive foaming, which could lead to product loss. As soon as the mixture is complete, the freshly carbonated Cherry Coca-Cola is sent directly to the filling lines for packaging. However, this must be done under strictly controlled conditions to maintain carbonation and prevent oxidation, which could negatively affect the beverage's taste and shelf life. The next step is the bottling and canning process, where the freshly mixed Cherry Coca-Cola is transferred into its final packaging. This stage of production requires highly specialized machinery that can fill thousands of bottles and cans per minute while maintaining product integrity. The bottling and canning lines operate at incredible speeds, and every detail, from the fill level to the sealing process, must be executed with extreme precision. The filling process begins with the preparation of the containers. Whether the product is being packaged in aluminum cans, plastic PET bottles, or glass bottles, each type of packaging undergoes a thorough cleaning and sterilization process before being filled. In the case of aluminum cans, they arrive at the factory in bulk and are depalletized before being sent through an inverted high-pressure air rinsing system that removes any dust or debris. For PET and glass bottles, the process is more intensive. PET bottles are first blown into shape from preforms using heated molds, while glass bottles go through a multi-step washing process that includes detergent cleaning, high-temperature rinsing, and sterilization with ozone-treated water. Once the containers are sanitized and ready for filling, they move along conveyor belts to the high-speed filling machines. These machines operate with incredible efficiency, using precision nozzles to dispense the exact amount of Cherry Coca-Cola into each container. One of the biggest challenges in this step is ensuring that carbonation is preserved during filling. To prevent excessive foaming and carbonation loss, the filling machines use counter-pressure technology. This involves pressurizing the container with CO2 before filling it with the beverage, ensuring that the carbonation remains intact and that there is minimal oxygen exposure. As the bottles and cans are filled, they are closely monitored by sensors and automated quality control systems to ensure that the correct fill levels are maintained. Any underfilled or overfilled containers are automatically rejected from the line. The next critical step is sealing, where each container is securely closed to lock in freshness. For aluminum cans, an automated seaming machine places a lid on top of the can and crimps it into place, creating an airtight seal. For plastic bottles, tamper-evident caps are applied using high-speed capping machines, while glass bottles are typically sealed with either twist-off metal caps or traditional crown caps. Immediately after sealing, the filled containers go through a pasteurization or cold sterilization process depending on the packaging type and regional regulations. In some cases, Cherry Coca-Cola undergoes flash pasteurization, where the beverage is rapidly heated and cooled to kill any potential microorganisms without altering the taste. However, for many markets, Coca-Cola products are aseptically filled, meaning that the entire bottling process is conducted under sterile conditions, eliminating the need for heat treatment. Once the sealing and sterilization process is complete, the bottles and cans move to the labeling and packaging stage. This is where branding and product information are applied to each container, ensuring that the final product meets regulatory requirements and maintains Coca-Cola's iconic visual identity. Now that the Cherry Coca-Cola has been bottled and sealed, the next phase of the manufacturing process focuses on quality control and inspection. Every single can and bottle must meet Coca-Cola's strict global quality standards before it can be shipped to retailers. This process involves multiple layers of testing, from automated inspections on the production line to detailed laboratory analysis conducted by food scientists. Even the smallest deviation in taste, carbonation level, or packaging integrity can result in a batch being rejected, ensuring that only the highest quality product reaches consumers. The first step in quality control takes place immediately after the filling and sealing process. High-speed vision inspection systems are installed along the conveyor belts, using advanced cameras and sensors to examine each bottle and can for defects. These systems check for issues such as underfilled or overfilled containers, misaligned caps, dents in cans, or improperly applied labels. If a container does not meet specifications, it is automatically removed from the line by a rejection mechanism. This automated inspection process allows for the real-time elimination of defective products, preventing inconsistencies from reaching the market. Another crucial quality control measure is the carbonation and pressure test. Since Cherry Coca-Cola's signature fizz is one of its defining characteristics, it is essential to ensure that each bottle and can contains the correct amount of dissolved CO2. To verify this, a random selection of containers is taken off the production line and placed into a specialized testing chamber where their internal pressure is measured. If the pressure falls outside the acceptable range, this could indicate improper carbonation levels, a sealing defect, or temperature fluctuations during the filling process. If an issue is detected, adjustments are made to the carbonation equipment to maintain consistency across the batch. Next, samples from each production run are sent to the on-site laboratory for detailed chemical and sensory analysis. Here, trained food scientists perform a variety of tests to confirm that the Cherry Coca-Cola meets Coca-Cola's strict formulation guidelines. One of the first tests conducted is the Brix test, which measures the concentration of dissolved sugars in the beverage. Since Cherry Coca-Cola has a carefully calibrated sweetness level, any deviation in the Brix measurement could indicate an incorrect syrup-to-water ratio, requiring adjustments in the proportioner. Another key laboratory test is pH analysis. The acidity of Cherry Coca-Cola is a crucial component of its taste, and this is largely controlled by the phosphoric acid content. A pH meter is used to measure the beverage's acidity, ensuring that it falls within the required range. Any variation in pH can significantly affect the drink's flavor balance, so this test is performed regularly to maintain consistency. Sensory evaluation is another critical aspect of quality control. A panel of trained taste testers, known as a sensory panel, is responsible for conducting blind taste tests to ensure that each batch of cherry Coca-Cola matches the expected flavor profile. These experts are highly trained to detect even the slightest differences in sweetness, acidity, carbonation, and cherry flavor intensity. They compare samples from the production line with reference samples from previous batches, ensuring that the taste remains uniform across all locations. If any inconsistencies are detected, adjustments are made to the formulation or processing parameters before the product is released for distribution. Packaging integrity is also a major focus of the quality control process. Even if the beverage itself meets all specifications, the packaging must be flawless to ensure product safety and shelf stability. To test this, random samples of filled bottles and cans undergo extreme stress testing. For plastic bottles, drop tests are conducted to simulate potential impacts during transportation. The bottles are dropped from various heights to ensure that they do not crack, leak, or experience cap failure. Cans are subjected to compression tests, where a machine applies controlled pressure to verify their structural integrity. If a can is too weak, it could deform or burst under normal handling conditions. If it is too rigid, it could indicate an issue with the aluminum thickness or the pressurization process. These tests help ensure that every container is durable enough to withstand shipping, storage, and handling by consumers. Another important quality control step is microbiological testing. Although cherry Coca-Cola's high acidity and carbonation naturally inhibit microbial growth, samples are still tested for the presence of bacteria, yeast, or mold. Microbiological testing is performed in a sterile laboratory environment where beverage samples are incubated under controlled conditions to detect any signs of microbial contamination. Even though Coca-Cola products are manufactured in sterile conditions, this extra layer of safety ensures that no contamination occurs at any stage of production. After all of these quality control tests have been completed, the final step before distribution is the batch coding and tracking process. Each bottle and can is printed with a unique production code that contains information about the manufacturing date, production line, and facility location. This allows Coca-Cola to track every product from the factory to store shelves. If an issue is ever discovered in a specific batch, this coding system enables rapid identification and recall of affected products. Once the cherry Coca-Cola has passed all quality control tests, the final phase of production involves packaging and distribution. This step ensures that the product is properly grouped, protected, and efficiently transported from the factory to retailers worldwide. The packaging process is highly automated and designed to handle the massive volume of cherry Coca-Cola produced daily while maintaining efficiency, accuracy, and product integrity. The first step in packaging is grouping the bottles and cans into multi-packs. Depending on the market and retail preferences, cherry Coca-Cola is sold in a variety of formats, including single cans, 6-packs, 12-packs, and larger 24-pack cases. The process begins with an automated system that arranges the bottles or cans into the correct configuration for packaging. High-speed robotic arms carefully align the containers into precise rows, ensuring uniformity before wrapping or boxing. These systems are programmed to adjust the layout based on production requirements, allowing flexibility in the types of multi-packs produced. For aluminum cans, a shrink wrapping system is used to bundle them together into multi-packs. The cans pass through a conveyor where they are tightly wrapped in a thin but durable layer of plastic film. This film is then heated in a specialized tunnel, shrinking it around the cans to create a secure and tamper-proof bundle. This method provides stability during transportation while allowing consumers to easily separate individual cans when needed. In some cases, paperboard carriers are used instead of plastic shrink wrap, particularly in regions where sustainability initiatives encourage the reduction of plastic packaging. These carriers are die-cut to hold the can securely while allowing easy removal. For plastic bottles, the process differs slightly. Many multi-packs of plastic bottles are held together using plastic rings or shrink-wrapped trays. Larger cases of cherry Coca-Cola bottles are placed into corrugated cardboard boxes for additional protection. The use of recyclable materials is prioritized wherever possible to reduce environmental impact. Coca-Cola has implemented sustainable packaging solutions such as biodegradable plant-based plastics and recyclable wrapping materials to minimize waste. Some factories have also introduced lighter weight PET bottles that require less plastic while maintaining the same durability, further contributing to environmental goals. Once the cherry Coca-Cola bottles and cans are securely packed, they move to the palletization stage. A palletizer is a large automated machine that carefully stacks the packaged products onto wooden or plastic pallets in an optimized arrangement for stability. This process ensures that products do not shift or fall during transport. Each pallet is carefully configured to maximize space while maintaining structural integrity. The palletizer is programmed to create stable layers of product, with each row strategically positioned to distribute weight evenly. After the pallets are loaded, they are wrapped with industrial-strength plastic film to keep them secure. This stretch wrapping process ensures that the products remain stable during transport. In some cases, pallets are reinforced with corner protectors for additional stability, particularly when shipping long distances. Some facilities also use robotic pallet wrappers, which automatically detect the height and dimensions of each pallet to apply the precise amount of stretch film required for stability without excessive material use. Once wrapped, the pallets are labeled with tracking codes and barcodes that contain critical shipment information, including the product type, batch number, expiration date, and destination details. These labels ensure that the inventory can be accurately tracked throughout the supply chain, reducing the risk of misdelivery or loss. The tracking system also allows retailers to quickly verify shipments upon arrival and enables Coca-Cola to monitor stock movement and demand trends. The next step is warehouse storage and inventory management. Once the cherry Coca-Cola pallets are prepared, they are transported via forklifts to massive storage warehouses. These warehouses are temperature controlled to protect the beverage from excessive heat or humidity, which could affect carbonation levels or packaging integrity. Temperature regulation is especially important in regions with extreme climates, as fluctuations in temperature could cause the CO2 in the beverage to expand or contract, potentially leading to leaks or compromised carbonation. Advanced inventory management systems track every pallet, using barcodes and RFID technology to ensure efficient organization and retrieval. These systems automatically log incoming and outgoing shipments, allowing real-time monitoring of stock levels. Warehouses are organized using automated retrieval systems that move pallets using robotic arms and conveyor systems, further increasing efficiency in high-volume distribution centers. Once the products are stored, the logistics and distribution phase ensures that cherry Coca-Cola reaches retailers and consumers as quickly as possible. The logistics team carefully plans delivery routes based on demand, ensuring that distribution centers and retail locations receive fresh stock on schedule. The distribution model varies depending on the region, with some locations utilizing central distribution hubs that serve multiple retailers, while others ship directly from production facilities to large supermarket chains and wholesalers. Trucks are loaded with pallets of cherry Coca-Cola according to a strict loading schedule, ensuring that the oldest inventory is shipped first to maintain freshness. The loading process is carefully coordinated to optimize space while keeping products stable during transit. Many of these trucks are refrigerated or climate controlled, particularly in warmer regions, to prevent heat exposure that could compromise product quality. In some cases, insulated truck liners are used instead of full refrigeration, allowing for temperature control without the added energy cost of refrigerated transport. The Coca-Cola process begins long before the beverage reaches the consumer, starting with the sourcing of raw ingredients and the preparation of the secret formula. The recipe is one of the most closely guarded trade secrets in the world, known only to a select few individuals. However, while the exact proportions of the ingredients remain undisclosed, the general components are well understood. Carbonated water, high fructose corn syrup or sugar, caramel color, phosphoric acid, natural flavors, and caffeine. The first step in manufacturing Coca-Cola is obtaining and preparing these ingredients. Water is the most important component, making up the majority of the drink. It must be purified to remove any impurities before being used in the production process. This is done through a series of filtration and purification steps, including sand filtration, carbon filtration, and reverse osmosis. These processes remove sediments, chlorine, organic compounds, and any potential contaminants, ensuring that only the purest water is used in Coca-Cola's production. The water purification process is vital because any variation in water quality could affect the final taste of the beverage. Once the water has been purified, it is ready to be mixed with the other ingredients. The syrup preparation process begins in a separate area of the factory, where high fructose corn syrup or sugar is combined with caramel coloring, phosphoric acid, and natural flavors. The caramel color gives Coca-Cola its distinct deep brown appearance, while phosphoric acid contributes to its tartness. The natural flavors used in Coca-Cola are a closely guarded secret, but they are essential in creating the beverage's unique taste. The caffeine is also added during this stage, ensuring that the drink maintains its signature stimulating effect. After the syrup is prepared, it must be carefully measured and mixed with the purified water. This is done through an automated batching system that ensures the precise ratio of syrup to water. The mixture is then subjected to a process called de-aeration, which removes any trapped air that could affect carbonation and shelf stability. This step is crucial because any excess air can lead to inconsistencies in taste and texture. Next, the mixture undergoes carbonation, one of the most important steps in the manufacturing process. Carbonation is achieved by injecting carbon dioxide into the liquid under controlled pressure and temperature conditions. The level of carbonation must be carefully calibrated to ensure that Coca-Cola has the right amount of fizziness. The CO2 used in this process is food grade and purified to remove any impurities. This step requires precision because too much or too little carbonation can alter the drink's mouthfeel and overall experience. Once the beverage has been carbonated, it is ready for bottling and packaging. However, before this can happen, the bottles or cans must be thoroughly cleaned and sterilized. This is a critical step in ensuring product safety and hygiene. Factories typically use high-pressure water jets and a sterilizing solution to clean the bottles before they are filled. Any residue or foreign particles in the bottles could compromise the quality of the drink, so this cleaning process is carefully monitored. With the bottles prepared, the filling process begins. The carbonated Coca-Cola mixture is dispensed into bottles or cans using high-speed filling machines that operate with incredible precision. The filling process must be conducted under controlled conditions to prevent foaming and loss of carbonation. The machines are designed to fill each container with the exact volume of liquid, ensuring consistency across all units. The filled bottles are then capped immediately to preserve carbonation and freshness. After capping, the bottles go through a labeling and coding process. Labels are applied to the bottles using automated machinery, and each bottle is imprinted with a date code to indicate its production date and best before date. This coding process helps with inventory management and quality control, allowing factories to track each batch of production. The labels are carefully inspected to ensure they are applied correctly, as any misaligned or missing labels can lead to packaging errors. Once labeled, the bottles move through a quality control checkpoint where they are inspected for any defects. This inspection process involves both human oversight and automated systems. High-speed cameras and sensors check for issues such as incorrect fill levels, damaged bottles, or improperly sealed caps. If any defects are detected, the affected bottles are removed from the production line to prevent them from reaching consumers. The quality control stage is one of the most critical aspects of Coca-Cola manufacturing, as it ensures that only products meeting the highest standards make it to market. After passing inspection, the bottles are packed into crates or cartons for distribution. The packaging process is fully automated, with robotic arms and conveyor belts handling the movement of products. The bottles are grouped into packs, shrink-wrapped for protection, and stacked onto pallets for transportation. The factory's logistics system ensures that the packaged products are efficiently stored and transported to distribution centers, where they are shipped to retailers, restaurants, and vending machines. The manufacturing process of Coca-Cola is designed for efficiency and precision at every stage. Factories are equipped with advanced technology and highly automated systems to ensure that production runs smoothly and consistently. Every step, from ingredient preparation to final packaging, is carefully monitored to maintain quality and safety standards. The final step before distribution involves conducting random sampling and additional quality control tests to ensure that the beverage meets Coca-Cola's strict standards. Samples are taken from each batch and tested in a laboratory for factors such as acidity, carbonation levels, and taste consistency. These tests help verify that the product remains true to Coca-Cola's signature flavor profile. If any deviations are found, adjustments are made to maintain quality. Coca-Cola factories operate around the clock, producing millions of bottles per day to meet global demand. The entire process is streamlined for maximum efficiency, ensuring that consumers receive fresh, high-quality beverages every time they purchase a bottle of Coca-Cola. The company places a strong emphasis on sustainability, incorporating water recycling and energy-efficient practices into its production processes. Water conservation efforts, CO2 recapture systems, and waste reduction initiatives help minimize the environmental impact of Coca-Cola manufacturing. Once the filled and capped bottles of Coca-Cola have undergone the initial stages of quality control, they move to an advanced inspection phase, where both automated systems and human supervisors ensure that every bottle meets the company's stringent standards. At this point, the bottles or cans are carefully checked for fill level accuracy, seal integrity, and carbonation retention. Sophisticated machines equipped with high-speed cameras analyze thousands of bottles per minute, identifying any anomalies such as underfilled or overfilled bottles, leaks, or incorrectly applied caps. If a defect is detected, the bottle is automatically removed from the production line and sent to a separate area for further evaluation. In cases where minor adjustments can be made, such as reapplying a cap that wasn't sealed properly, corrective measures are taken before the bottle is returned to the production process. However, if the defect compromises the quality of the beverage, the bottle is discarded to maintain consistency and uphold Coca-Cola's reputation for high-quality products. Parallel to this, another critical process occurs in the factory: batch testing. Randomly selected bottles from each production run are taken to an on-site laboratory, where they undergo extensive chemical and sensory analysis. Laboratory technicians assess factors such as pH levels, sugar concentration, carbonation levels, and overall taste profile to confirm that the beverage aligns perfectly with Coca-Cola's standardized formulation. Any deviation from the expected specifications results in a thorough investigation, ensuring that the issue is promptly identified and corrected. Once the bottles pass quality checks, they move on to secondary packaging. Coca-Cola is typically sold in various formats, including individual bottles, 6-packs, 12-packs, and even bulk cartons containing dozens of bottles or cans. High-speed automated packaging machines arrange the bottles into their designated configurations, wrapping them in plastic film or placing them into cardboard carriers. These machines operate with incredible precision, ensuring that every package is neatly assembled and securely sealed. At this stage, sustainability efforts come into play. Coca-Cola has invested heavily in reducing plastic waste and optimizing its packaging materials. Many of the plastic bottles used in Coca-Cola production are made from recycled PET, and the company continuously works toward increasing the percentage of recycled content in its packaging. In some regions, Coca-Cola also uses plant-based plastic materials to further minimize its environmental impact. The secondary packaging materials, such as cardboard cartons, are often sourced from recycled paper products, aligning with Coca-Cola's commitment to sustainability. Once packaged, the finished products are transported through a network of conveyor belts to a distribution staging area within the factory. Here, robotic palletizers stack the products onto pallets, organizing them efficiently for shipping. These robots use advanced algorithms to optimize space utilization, ensuring that the maximum number of products can be transported with minimal waste. The palletized products are then wrapped in protective plastic film to keep them secure during transit. The next step in the Coca-Cola manufacturing process is logistics and distribution. The company operates a vast global supply chain, with each factory producing beverages that are distributed to local and regional markets. Trucks, trains, and even cargo ships transport Coca-Cola products to distribution centers, warehouses, and retail locations around the world. The logistical network is meticulously planned to minimize transportation costs and reduce the carbon footprint of product distribution. Before shipping, warehouse personnel use barcode scanning systems and inventory management software to track every pallet of Coca-Cola. Each unit is assigned a unique barcode that corresponds to its production date, batch number, and destination. This tracking system enables the company to efficiently manage stock levels and quickly address any issues that may arise, such as recalls or shipment delays. In many cases, Coca-Cola products are delivered directly to retailers, including supermarkets, convenience stores, and vending machine operators. The company's extensive distribution network ensures that consumers can access fresh Coca-Cola virtually anywhere in the world. To maintain the freshness of the beverage, Coca-Cola implements a strict first-in, first-out inventory system, which prioritizes the sale of older stock before newer stock reaches store shelves. While Coca-Cola's distribution network ensures that the beverage reaches consumers efficiently, the manufacturing process doesn't end once the product leaves the factory. Coca-Cola factories also focus on sustainability initiatives aimed at reducing environmental impact. Water conservation is a major priority, given that water is the primary ingredient in Coca-Cola. Factories implement advanced water recycling systems, allowing them to treat and reuse water for non-product related processes such as equipment cleaning and cooling. Energy efficiency is another key focus. Many Coca-Cola plants utilize renewable energy sources such as solar and wind power to offset electricity consumption. The company also invests in energy-efficient machinery, reducing the overall carbon footprint of its manufacturing operations. Additionally, Coca-Cola works with local communities to support environmental sustainability initiatives such as reforestation programs and water replenishment projects. Another important aspect of Coca-Cola's manufacturing process is its adherence to strict food safety regulations. Factories comply with global food safety standards, including the Hazard Analysis and Critical Control Point System, which identifies and mitigates potential risks in food production. Employees undergo regular training on hygiene protocols, and strict sanitation measures are enforced throughout the facility. Production areas are regularly disinfected, and equipment is thoroughly cleaned after each batch to prevent cross-contamination. Coca-Cola also invests in research and development to continuously refine its production processes. Scientists and engineers work to optimize ingredient formulations, improve packaging materials, and enhance the efficiency of manufacturing operations. Innovation plays a crucial role in Coca-Cola's success, allowing the company to adapt to changing consumer preferences and market demands. For example, in response to growing health-conscious trends, Coca-Cola has introduced reduced sugar and zero sugar variants, all of which undergo the same rigorous manufacturing process as the original formula. One of the most impressive aspects of Coca-Cola's manufacturing process is its ability to maintain consistency across different regions. Regardless of where Coca-Cola is produced, whether in North America, Europe, Asia, or Africa, the taste and quality of the beverage remain the same. This consistency is achieved through strict adherence to Coca-Cola's global manufacturing standards, which dictate precise ingredient ratios, quality control measures, and production techniques. Each factory is regularly audited to ensure compliance with these standards, ensuring that consumers receive the same great-tasting Coca-Cola wherever they are in the world. Despite the high level of automation in Coca-Cola factories, human oversight remains essential. Factory workers play a crucial role in monitoring production lines, troubleshooting issues, and ensuring that operations run smoothly. From syrup blending technicians to quality control inspectors, every employee contributes to the success of the manufacturing process. Safety is also a top priority, with factories implementing comprehensive occupational health and safety programs to protect workers from potential hazards. The production of Coca-Cola is a complex and finely tuned process that extends beyond simply mixing ingredients and filling bottles. It involves numerous specialized stages that ensure the beverage maintains its signature taste, quality, and safety. As the bottled or canned Coca-Cola moves through the factory, the focus remains on maintaining efficiency, consistency, and sustainability. One of the key elements of Coca-Cola's production process is the careful management of carbonation. The carbon dioxide used to carbonate the beverage is sourced from food-grade suppliers and must meet strict purity standards. Maintaining consistent carbonation levels is critical because it affects the drink's texture, mouthfeel, and overall sensory experience. Carbonation is carefully controlled during the filling process to ensure that the right amount of CO2 is dissolved into the liquid. If the pressure or temperature is not properly maintained, the carbonation can dissipate too quickly, leading to a flat-tasting beverage. To prevent this, Coca-Cola factories use pressurized filling machines that ensure minimal CO2 loss as the beverage is transferred into bottles or cans. Once filled and capped, Coca-Cola bottles move through a final stage of quality assurance before they are packed and prepared for shipment. Each bottle is subjected to a high-speed laser inspection system that verifies the presence of the cap, ensures proper sealing, and checks for any defects in the glass or plastic. These laser inspection systems can detect even microscopic irregularities that might not be visible to the human eye, helping prevent faulty products from reaching the market. One of the most crucial aspects of Coca-Cola's manufacturing process is ensuring uniformity across all production facilities worldwide. To achieve this, the company employs a centralized quality control system that enforces strict guidelines for ingredient sourcing, syrup production, water purification, and carbonation. Each factory follows a standardized protocol, and periodic audits are conducted to verify compliance. This rigorous attention to detail ensures that a bottle of Coca-Cola produced in the United States tastes identical to one manufactured in Japan, South Africa, or Brazil. While consistency is a priority, Coca-Cola also tailors its formulation slightly to accommodate regional preferences and regulatory requirements. In some countries, the beverage is sweetened with high fructose corn syrup, while in others, cane sugar is used. Additionally, the amount of caffeine in the beverage may vary slightly depending on local guidelines. Despite these subtle differences, the core flavor profile remains the same, thanks to the precise blending of the secret formula. After passing through final quality control checks, Coca-Cola bottles and cans are directed toward packaging and palletizing. At this stage, packaging automation plays a key role in optimizing efficiency. Modern Coca-Cola factories use robotic arms and conveyor systems to sort, pack, and shrink wrap the products into multi-packs, cases, or crates. These machines work at incredible speeds, sometimes processing thousands of bottles per minute. Sustainability efforts are heavily integrated into the packaging process. Coca-Cola has made significant strides in reducing its environmental impact by using lightweight packaging materials, increasing the use of recycled plastics, and investing in refillable bottle programs. Many Coca-Cola factories have adopted a closed-loop recycling system in which used plastic bottles are collected, cleaned, and reprocessed into new bottles. This reduces reliance on virgin plastic and minimizes waste. Once the Coca-Cola products are packed and palletized, they are moved to the warehouse storage area within the factory. This area is carefully temperature controlled to preserve the beverage's freshness and carbonation levels. Coca-Cola's warehouse management system tracks each pallet's movement, ensuring that products are stored efficiently and dispatched in a timely manner. From the warehouse, Coca-Cola products are distributed through a highly organized logistics network. The company utilizes a combination of trucks, rail transport, and shipping containers to move its products from manufacturing facilities to regional distribution centers. These centers act as hubs that supply retailers, restaurants, and vending machines with fresh stock. Coca-Cola's logistics team uses advanced forecasting software to predict demand and optimize delivery routes, reducing fuel consumption and improving efficiency. Once Coca-Cola reaches retail locations, the company's work is not finished. Coca-Cola employs a global network of merchandising teams that ensure products are displayed prominently in stores, kept at the right temperature, and stocked in vending machines and coolers. These teams also monitor product rotation, ensuring that older stock is sold first to maintain freshness. Another key element in Coca-Cola's manufacturing and distribution process is its commitment to reducing water usage. Water stewardship is a major initiative for Coca-Cola, as the company relies heavily on water as its primary ingredient. Many Coca-Cola plants have implemented state-of-the-art water reclamation systems that allow them to recycle and reuse water in non-product applications such as equipment cooling and bottle washing. These efforts help minimize water waste and ensure responsible water management. In addition to water conservation, Coca-Cola has also invested in reducing its overall carbon footprint. Many of its manufacturing plants have adopted energy-efficient technologies, including solar panels, wind turbines, and advanced heat recovery systems. These measures help Coca-Cola decrease its reliance on fossil fuels and reduce greenhouse gas emissions. The company has also transitioned many of its delivery trucks to hybrid or electric models to further lower its environmental impact. While Coca-Cola's manufacturing process is highly automated, it still requires a skilled workforce to oversee operations. Factory employees play a crucial role in maintaining equipment, monitoring production lines, and conducting quality checks. They receive extensive training to ensure they understand food safety protocols, machinery operation, and emergency procedures. Coca-Cola places a strong emphasis on worker safety, implementing strict guidelines to protect employees from potential hazards associated with high-speed machinery and industrial production environments. The level of precision required to produce Coca-Cola at such a massive scale is truly remarkable. Every ingredient, every machine, and every worker plays a vital role in ensuring that millions of bottles of Coca-Cola can be produced and distributed each day without compromising quality. The company's ability to manufacture its beverage with such consistency across different regions is a testament to the effectiveness of its standardized processes and advanced technology. Coca-Cola's manufacturing journey doesn't end once the product reaches consumers. The company continues to innovate, finding new ways to improve its production methods, reduce its environmental impact, and adapt to changing consumer preferences. Recent innovations include the development of plant-based plastic bottles, the introduction of lower-calorie and sugar-free alternatives, and improvements in energy-efficient bottling techniques. As Coca-Cola's manufacturing process continues beyond the bottling and packaging stages, the company remains focused on optimizing efficiency, reducing waste, and ensuring that every bottle that reaches the consumer meets its high standards. With millions of bottles and cans produced daily in factories around the world, Coca-Cola relies on a seamless integration of automated systems, rigorous quality control, and strategic logistics to maintain its position as one of the most recognizable beverages on the planet. One of the most important aspects of Coca-Cola's production process is its supply chain management. The company sources its ingredients from a global network of suppliers, ensuring that its factories receive high-quality raw materials consistently. The supply chain involves the coordinated movement of sugar or high-fructose corn syrup, caffeine, caramel coloring, phosphoric acid, and natural flavorings, all of which must be stored under precise conditions to maintain their integrity. The syrup used to create Coca-Cola is produced in specialized facilities known as concentrate plants. These plants manufacture the highly concentrated base syrup, which is then shipped to bottling facilities worldwide, where it is mixed with purified water and carbonated before packaging. Once the concentrate reaches the bottling plant, it is diluted with purified water following Coca-Cola's standardized formulation. The water undergoes extensive treatment to remove any impurities, ensuring that the final beverage maintains the same taste, regardless of where it is produced. The carbonation process is carefully monitored, as even a slight variation in CO2 levels can affect the drink's mouthfeel and effervescence. Coca-Cola's research and development teams continuously refine the carbonation techniques to ensure the perfect balance of bubbles in every sip. With the beverage ready for packaging, Coca-Cola utilizes a diverse range of bottling formats to cater to different consumer preferences. The company produces its beverages in glass bottles, aluminum cans, and PET plastic bottles, each with its own specific manufacturing process. Glass bottles, for example, require a specialized filling line that ensures the bottles are sterilized before filling, capped securely, and transported safely. PET bottles undergo a process called blow molding, in which small preforms of plastic are heated and expanded into the shape of a full-sized bottle using high-pressure air. This method allows Coca-Cola to produce lightweight, durable bottles that are both cost-effective and recyclable. As the bottles and cans move through the high-speed production lines, they are continuously monitored by automated inspection systems. These systems use infrared sensors, X-ray technology, and high-speed cameras to detect any irregularities in fill levels, cap placement, and structural integrity. Bottles that do not meet Coca-Cola's quality standards are automatically removed from the line and discarded or recycled. This attention to detail ensures that only perfect products reach consumers. After being filled, capped, and labeled, Coca-Cola products are assembled into multi-packs or crates for easier handling and distribution. The packaging process is designed for maximum efficiency, with robotic arms swiftly arranging the bottles into their respective cases. Sustainability remains a key focus during this stage, with Coca-Cola implementing measures to reduce plastic waste by using lightweight packaging materials and increasing the use of recycled content. Many Coca-Cola plants have adopted a closed-loop recycling system, in which post-consumer PET bottles are collected, cleaned, and transformed into new bottles. This initiative significantly reduces the company's reliance on virgin plastics and helps minimize environmental impact. Once packaged, the products are transported to warehouse storage areas, where they are organized based on expiration dates and distribution routes. Coca-Cola follows a strict first in, first out inventory system to ensure that older stock is shipped out before newer stock, preventing waste and maintaining freshness. The company's advanced inventory management system tracks every case, ensuring that retailers receive the right products at the right time. From the warehouse, Coca-Cola products embark on their journey to retailers, supermarkets, vending machines, and restaurants. The company's logistics team meticulously plans transportation routes to optimize delivery efficiency and reduce fuel consumption. Coca-Cola operates a fleet of delivery trucks, many of which are equipped with refrigeration units to keep beverages cool during transit. In some regions, Coca-Cola has introduced electric delivery trucks to further minimize its carbon footprint. While Coca-Cola's production process is largely automated, human oversight remains essential at every stage. Factory employees play a critical role in ensuring that operations run smoothly, troubleshooting machinery issues, and maintaining stringent hygiene standards. Workers undergo regular training to stay up to date with food safety protocols, equipment operation, and emergency response procedures. The company prioritizes worker safety, implementing strict guidelines to protect employees from potential hazards associated with high-speed production lines and industrial equipment. Coca-Cola's commitment to sustainability extends beyond its factories and supply chain. The company actively invests in water conservation projects, renewable energy initiatives, and recycling programs to reduce its overall environmental impact. In many regions, Coca-Cola collaborates with local communities to replenish water sources and support biodiversity conservation efforts. For every liter of water used in its production process, Coca-Cola works to return an equivalent amount to the environment through water stewardship initiatives. Another area of continuous improvement within Coca-Cola's manufacturing process is the development of innovative beverage formulations. In response to evolving consumer preferences, Coca-Cola has expanded its product portfolio to include sugar-free and low-calorie alternatives. The production of these variations follows a similar process to the original formula, with slight adjustments made to accommodate different sweeteners and flavor profiles. The introduction of Coca-Cola Zero Sugar and Diet Coke has required modifications to syrup formulation and taste testing procedures to ensure that these alternatives maintain the same crisp, refreshing experience as the classic version. Beyond traditional retail, Coca-Cola is also distributed through vending machines and fountain dispensers. The production of Coca-Cola syrup for fountain machines follows a slightly different process, as the syrup is shipped in concentrated form to restaurants and fast food chains, where it is mixed with carbonated water on site. This method allows for efficient storage and reduces packaging waste. Cake production begins with the selection and sourcing of high-quality raw ingredients. Flour is the primary component, usually made from wheat, and it is carefully milled to achieve the right texture and protein content for cake production. Sugar is another crucial ingredient, providing sweetness and structure to the cake batter. Granulated sugar, powdered sugar, and sometimes liquid glucose are used depending on the specific type of cake being manufactured. Eggs, either fresh or in liquid or powdered form, contribute to the structure and moisture of the cake. Dairy ingredients such as butter, milk, and cream enhance the flavor and texture. Vegetable oils, often used as a substitute for butter in large-scale production, ensure a longer shelf life and a softer crumb. Leavening agents such as baking powder or baking soda are essential to create the airy texture that defines a good cake. Flavoring agents including vanilla extract, cocoa powder, fruit purees, and artificial flavors are precisely measured and incorporated to achieve consistent taste profiles. Before production begins, the factory undergoes rigorous sanitation procedures to ensure a clean environment. Production lines, mixers, conveyors, and baking equipment are all sterilized to prevent contamination. The ingredients are stored in temperature-controlled silos or containers, with automated systems regulating their dispensation. Large-scale cake production begins with precise ingredient measurement. Factories utilize automated weighing systems that ensure every batch maintains the correct proportions. Dry ingredients like flour, sugar, and leavening agents are sifted and aerated to remove clumps before entering the mixing phase. Liquid ingredients such as eggs, milk, and oils are stored in large tanks and piped directly into the mixing units. Mixing is a critical step in cake production, requiring advanced industrial mixers that can handle large volumes while maintaining consistency. The process varies depending on the type of cake being produced. Sponge cakes require aeration to create a light texture, while denser cakes need thorough mixing to ensure a uniform crumb. Continuous batter mixing systems operate at high speeds, gradually incorporating the ingredients in precise sequences. Some factories use planetary mixers, which rotate on multiple axes to create an even distribution of ingredients. Ribbon blenders or high shear mixers may also be used to emulsify fat-based batters. Mixing times and speeds are carefully programmed to avoid overmixing, which can result in tough cakes. Once the batter reaches the desired consistency, it is transferred through a network of pipes or conveyor belts to the depositing machines. These machines portion the batter into molds, trays, or baking pans, ensuring uniformity in weight and shape. Modern cake factories employ volumetric or piston-based depositors that release precise amounts of batter with each cycle. Some machines are equipped with multiple nozzles to fill several trays simultaneously, increasing efficiency. At this stage, additional ingredients such as fruit pieces, nuts, or chocolate chips may be incorporated, either mixed into the batter or sprinkled on top before baking. The filled molds or trays move along a conveyor system into industrial ovens. The baking process is meticulously controlled to achieve the desired texture and color. Tunnel ovens, rack ovens, and convection ovens are commonly used in large-scale cake production. Tunnel ovens, which feature continuous conveyor belts that move cakes through different temperature zones, ensure even baking. The temperature and humidity levels within the ovens are carefully regulated to promote consistent rising and moisture retention. During baking, leavening agents react with heat to create gas bubbles, causing the batter to expand. The Maillard reaction, a chemical process between amino acids and sugars, develops the golden brown crust and enhances flavor. After baking, the cakes must be cooled to prevent condensation and sogginess. Cooling tunnels equipped with controlled airflow rapidly bring down the temperature while preventing excessive moisture loss. The cooling process is crucial because cakes that are too warm can compromise the integrity of icing or packaging. Factories often employ spiral cooling conveyors that maximize space efficiency while allowing cakes to cool gradually. Some facilities use blast coolers that rapidly reduce temperatures without affecting texture. Once sufficiently cooled, cakes may be removed from their molds using automated depanning systems. These machines use gentle vibrations, air pressure, or mechanical arms to lift cakes without damaging their shape. Before proceeding to decoration, quality control checks are performed. Cakes are inspected for uniformity in size, shape, and color. Advanced vision inspection systems use cameras and sensors to detect defects such as uneven surfaces or air pockets. Weight sensors ensure each cake meets the required specifications. Any cakes that do not pass quality checks are either reworked or discarded. Some factories employ metal detectors and X-ray scanners to identify foreign objects or contaminants. The decoration process varies depending on the type of cake being produced. For layer cakes, automated slicing machines cut the cakes horizontally to create multiple layers. These layers are then conveyed to filling stations, where robotic arms or extrusion nozzles apply cream, fruit preserves, or ganache. In some cases, conveyor systems transport the cakes through enrobing machines, which coat them in a layer of chocolate or glaze. Icing and frosting are applied using precision nozzles, spatula robots, or rotary icing machines. Buttercream, fondant, or whipped cream is spread evenly across the surface. Some factories use airbrush systems to add gradients of color or decorative effects. For cakes that require intricate designs, programmable robotic arms pipe decorative elements with incredible precision. Sprinkles, chocolate shavings, or edible glitter may be added using automated dispensers. At this stage, cakes intended for retail packaging may be pre-sliced using ultrasonic cutting machines. These machines utilize high-frequency vibrations to create clean, precise cuts without crushing the delicate cake structure. Pre-sliced cakes are often packaged in individual portions for convenience. Cakes intended for long shelf life may undergo additional processes such as modified atmosphere packaging, which removes oxygen from the packaging to slow down spoilage. Packaging is a crucial step in maintaining product freshness and ensuring a visually appealing presentation. Cakes are carefully transferred onto packaging conveyors, where they are placed into plastic trays, paperboard cartons, or clamshell containers. Flow wrapping machines seal individual cakes in airtight film to extend shelf life. For larger cakes, shrink wrapping or rigid plastic domes provide protection during transportation. Labels with product information, barcodes, and expiration dates are applied using automated labeling machines. Before distribution, final quality control checks are performed. Cakes are weighed again to confirm portion accuracy. Some factories conduct random sampling to test for taste, texture, and moisture content. Microbiological testing may be carried out in on-site laboratories to ensure food safety compliance. Cakes are then organized into cartons or crates and palletized for transportation. Temperature-controlled storage areas maintain product freshness before shipment. Depending on distribution requirements, cakes may be transported in refrigerated trucks to prevent spoilage. Large-scale manufacturers distribute cakes to supermarkets, bakeries, and retailers across vast geographical areas. Once the cakes are packed and ready for distribution, they move through a final inspection stage to ensure that packaging integrity is maintained. Automated vision inspection systems scan the packaging for any defects, such as improper sealing, misaligned labels, or damage that could compromise product quality. Any faulty packages are removed from the production line to prevent them from reaching consumers. At this stage, lot numbers and expiration dates are printed onto the packaging using high-speed inkjet printers or laser etching machines, allowing for precise tracking and traceability. This is a critical aspect of food safety regulations, as it enables quick recalls in the unlikely event of contamination or quality issues. Once the cakes have passed all final quality control checks, they are transported to cold storage or distribution centers. Cakes that require refrigeration, such as those with fresh cream or perishable fillings, are stored in temperature-controlled environments to maintain freshness. These storage areas are monitored by advanced refrigeration systems that maintain optimal humidity and temperature levels. Cakes that have been designed for longer shelf life, such as those using modified atmosphere packaging, or preservatives may be stored at ambient temperatures before shipping. Distribution logistics are carefully planned to ensure that cakes reach their destination in perfect condition. Large-scale cake manufacturers work with refrigerated trucking fleets and logistics providers to manage transportation efficiently. Cakes are loaded onto pallets and organized based on their destination, with detailed inventory tracking ensuring that products arrive at the correct locations. In some cases, cakes are shipped directly to supermarkets, bakeries, or food service providers, while others are sent to central warehouses for further distribution. To minimize damage during transit, cakes are packed in sturdy shipping containers designed to absorb vibrations and prevent movement inside the truck. Upon arrival at their final destination, cakes are unpacked and stocked on store shelves or refrigerated display cases. Retailers follow strict storage guidelines to maintain freshness, ensuring that temperature-sensitive cakes are kept in chilled conditions and that all products are rotated based on their expiration dates. Many cakes are sold in pre-packaged formats, while others are displayed in bakery sections where customers can purchase whole cakes or slices. Supermarkets and bakery chains often use just-in-time inventory management systems to minimize waste and ensure a steady supply of fresh cakes. While the majority of factory-made cakes are mass-produced for supermarkets and retail stores, some facilities specialize in producing cakes for commercial bakeries, restaurants, and catering businesses. These cakes are often supplied in bulk, either as frozen cakes that can be thawed and decorated on site, or as partially finished products that can be customized before serving. This flexibility allows bakeries and food service providers to offer fresh cakes without the need for extensive in-house baking operations. The industrial cake making process has evolved significantly over the years, incorporating advanced automation, robotics, and data-driven quality control systems to improve efficiency and consistency. Modern factories utilize artificial intelligence and machine learning to analyze production data, predict maintenance needs, and optimize ingredient usage. Automated production lines can run continuously with minimal human intervention, reducing labor costs and increasing output capacity. One of the most significant innovations in large-scale cake production is the development of high-speed depositing and baking systems. Traditional cake production required separate steps for mixing, portioning, and baking, but modern inline systems integrate these processes seamlessly. For example, continuous mixing systems automatically adjust ingredient ratios based on real-time monitoring, ensuring that each batch maintains the perfect consistency. Depositing machines equipped with servo-driven technology can rapidly change portion sizes, allowing for the production of different cake varieties on the same production line. Baking technology has also advanced, with energy-efficient ovens that use infrared heating and precision airflow systems to achieve uniform baking. These ovens are designed to minimize heat loss, reducing energy consumption while maintaining consistent product quality. Some modern bakeries use hybrid ovens that combine conventional and microwave heating to speed up the baking process without compromising texture. In addition to traditional cakes, many factories produce specialty cakes that cater to specific dietary needs and preferences. Gluten-free cakes, for example, require dedicated production lines to prevent cross-contamination with wheat flour. These cakes use alternative flours, such as rice flour, almond flour, or tapioca starch, along with modified stabilizers to achieve the desired texture. Similarly, vegan cakes are made without eggs or dairy, relying on plant-based substitutes such as flaxseed, aquafaba, and non-dairy milk. Sugar-free and low-carb cakes are also growing in popularity, utilizing sugar alcohols or natural sweeteners like stevia to replace traditional sugar. The rise of personalized and custom cakes has led some factories to develop on-demand printing and decoration technologies. Edible ink printers can create intricate designs, logos, or images directly onto cake surfaces, making them ideal for special occasions or corporate branding. Robotic decorators equipped with artificial intelligence can replicate complex piping patterns, allowing for mass customization with minimal human intervention. Some facilities even offer direct-to-consumer cake ordering services where customers can customize flavors, fillings, and decorations before the cake is produced and shipped. Despite the high level of automation in modern cake production, human oversight remains essential to ensure quality and address any potential issues that arise during manufacturing. Skilled food technologists and quality assurance teams continuously monitor production parameters, conduct taste tests, and refine recipes to maintain consistency. Regular equipment maintenance and cleaning schedules are strictly followed to prevent contamination and ensure compliance with food safety standards. Sustainability is an increasing focus in the cake manufacturing industry, with many companies adopting eco-friendly practices to reduce their environmental impact. Ingredient sourcing has shifted towards sustainable palm oil, fair trade cocoa, and locally sourced dairy to support ethical farming practices. Factories are also investing in waste reduction strategies, such as repurposing cake scraps into secondary products like cake pops, or repackaging unsold cakes into discount bakery items. Some manufacturers have implemented water recycling systems and energy-efficient lighting to further minimize their carbon footprint. Packaging innovation is another area of focus, with a shift toward biodegradable and recyclable materials. Traditional plastic cake containers are being replaced with compostable trays, paper-based wraps, and plant-derived biofilms that maintain freshness while reducing plastic waste. Smart packaging solutions, such as freshness indicating labels and QR codes that provide traceability information, are also being explored to enhance the consumer experience. The demand for factory-made cakes continues to grow globally, driven by changing consumer lifestyles, convenience, and the increasing popularity of ready-to-eat desserts. Emerging markets are seeing a surge in industrial cake production as urbanization and income growth lead to higher demand for packaged bakery products. In response, cake manufacturers are expanding their production capacity, investing in new facilities, and adapting their offerings to regional taste preferences. The future of cake manufacturing is expected to see even greater advancements in automation, customization, and sustainability. 3D food printing technology is being explored as a potential innovation that could revolutionize cake decoration and design. AI-driven recipe development could allow manufacturers to create entirely new flavor profiles based on consumer preferences and sensory data. As consumer awareness of health and nutrition grows, factories may develop functional cakes fortified with protein, fiber, or probiotics to cater to evolving dietary trends. One of the most crucial aspects of large-scale cake manufacturing is maintaining absolute consistency across every batch. Consumers expect the same taste, texture, and appearance every time they purchase a cake from a particular brand, and this requires precise control over every stage of production. Factories employ automated recipe management systems that digitally store exact formulations, ingredient ratios, and process parameters. These systems interface directly with mixing and processing equipment, ensuring that every batch is prepared with the same level of precision. Advanced sensors monitor temperature, humidity, and ingredient dispersion, automatically adjusting machine settings if any deviations are detected. Mixing remains one of the most technologically advanced steps in the industrial cake production process. Continuous mixers, which operate non-stop to produce an unbroken stream of batter, have revolutionized large-scale baking. These machines ensure that ingredients are thoroughly combined without overworking the batter, preserving the delicate structure needed for cakes. In some cases, aeration systems introduce controlled amounts of air into the batter to achieve specific textures. The density and fluffiness of sponge cakes, for instance, depend on the precise incorporation of air during mixing. Factories may also use vacuum mixing technology to remove excess air bubbles and prevent inconsistencies. Once the batter is perfectly blended, it is transferred through high-speed piping systems to the depositing stations. These machines dispense exact portions of batter into baking molds, trays, or individual paper cups for cupcakes. The speed and precision of depositing machines play a critical role in maintaining efficiency, as even a small miscalculation in portioning can lead to product defects or waste. Some depositors use volumetric control, ensuring each mold receives an identical amount of batter, while others rely on piston-driven mechanisms to regulate flow. Factories that produce multiple cake varieties may use multi-head depositing machines capable of filling different molds simultaneously. At this stage, additional mix-ins or toppings may be incorporated. Fruit pieces, chocolate chips, or nuts are often added either before or after depositing, depending on the desired distribution within the cake. Some factories use automated dispensing units that sprinkle toppings evenly across the surface, while others employ injection systems that insert fillings into the center of the cake batter before baking. These injection methods are commonly used for filled cupcakes or specialty cakes with jam, custard, or chocolate centers. The baking process itself is highly controlled, with industrial ovens engineered to ensure even heat distribution. Tunnel ovens, which operate on a conveyor belt system, are the most commonly used in large-scale cake manufacturing. These ovens feature multiple temperature zones that gradually heat the cakes as they move through the baking chamber. The initial phase of baking involves rapid heat transfer to activate leavening agents and promote expansion. As the cakes progress through the oven, moisture is gradually released, setting the structure while maintaining softness. Humidity control is a critical factor in industrial baking. Cakes that lose too much moisture too quickly may become dry, while excess humidity can lead to underbaking or structural collapse. Factories use steam injection systems within ovens to maintain optimal baking conditions. Convection fans circulate hot air evenly, preventing hot spots and ensuring consistent coloration. Some advanced ovens incorporate infrared or microwave-assisted heating to accelerate baking times without compromising quality. Once the cakes emerge from the ovens, they must be cooled carefully to avoid textural inconsistencies. Cooling conveyors transport cakes through controlled environments where temperature and airflow are meticulously regulated. Spiral cooling systems, which maximize space efficiency by stacking conveyors in a vertical spiral, allow for gradual cooling while optimizing factory floor space. Some manufacturers use rapid cooling tunnels equipped with gentle air currents to quickly stabilize cakes intended for immediate packaging. At this stage, cakes may be trimmed, shaped, or portioned according to product specifications. High-speed ultrasonic slicing machines are used for precision cutting, ensuring that each slice maintains a clean edge without crumbling. For layer cakes, industrial slicers divide cakes horizontally, preparing them for filling and stacking. Cakes that require shaping, such as sheet cakes for pre-cut squares, are passed through automated cutting systems that use rotating blades or water jet technology for perfect uniformity. The decoration process is where cakes truly come to life, transforming from simple baked goods into visually appealing products ready for the market. Large-scale factories utilize a combination of robotic systems, automated icing machines, and human decorators for final touches. Buttercream, fondant, or chocolate coatings are applied using enrobing machines or precision icing nozzles. Rotary icing machines create smooth, consistent layers of frosting, while airbrush systems add gradients of color for a professional finish. For cakes requiring intricate designs, robotic decorators equipped with multi-axis arms can replicate complex piping patterns, flowers, or lettering with remarkable accuracy. These machines are programmed to follow specific designs stored in digital templates, allowing manufacturers to mass-produce cakes with customized elements. Some factories use edible ink printers to apply high-resolution images or logos onto cake surfaces, a popular technique for themed birthday cakes and corporate branding. Toppings and embellishments such as sprinkles, chocolate curls, or fruit slices are applied using automated dispensers. Some cakes may pass through a drizzling station where thin streams of chocolate or caramel are added for decorative effect. Cakes requiring additional layers of decoration, such as fondant appliques or edible figurines, are assembled by skilled workers in specialized decoration zones within the factory. Final quality control checks are conducted before packaging. Cakes are inspected for uniformity in shape, frosting consistency, and overall presentation. Some factories employ X-ray scanners and metal detectors to identify potential contaminants or foreign objects within the cakes. Weight sensors verify that each cake meets precise product specifications, and random sampling is conducted for taste testing and texture analysis. Packaging plays a vital role in preserving cake freshness and ensuring product protection during transportation. Depending on the type of cake, various packaging methods are employed. Flow wrapping machines encase individual cakes in airtight plastic film, extending shelf life by preventing exposure to air and moisture. Larger cakes may be placed in rigid plastic containers or cardboard boxes with clear windows for visual appeal. For frozen or refrigerated cakes, vacuum-sealed packaging is often used to lock in freshness. Modified atmosphere packaging, which replaces oxygen with nitrogen or carbon dioxide, helps prevent mold growth and extends shelf stability. Cakes destined for international markets may undergo additional protective measures, such as temperature-controlled shipping containers or specialized packaging to prevent movement during transit. Once packaged, cakes are palletized and loaded onto distribution trucks. Logistics teams coordinate shipments to ensure that products reach their destinations promptly. Some manufacturers supply cakes directly to retail stores, while others distribute them through central warehouses for regional distribution. Refrigerated transport is essential for cakes with perishable ingredients, while shelf-stable varieties are transported under standard conditions. The journey of a cake from the factory to the consumer's table is a testament to the efficiency and precision of modern food manufacturing. The combination of automation, rigorous quality control, and advanced baking technologies ensures that every cake maintains the same high standard of taste and appearance. As consumer preferences evolve, factories continue to innovate, developing new flavors, healthier alternatives, and environmentally sustainable production methods. As cakes leave the factory and make their way to retail stores, bakeries, and food service providers, a highly efficient distribution network ensures that they arrive in perfect condition. Logistics teams work closely with transportation providers to maintain strict temperature controls for cakes that require refrigeration. Cold chain management is essential for ensuring that cakes with fresh cream, custard, or perishable fillings remain safe and retain their intended texture. Refrigerated trucks are equipped with sensors that monitor temperature and humidity levels throughout the journey, providing real-time data to ensure compliance with food safety regulations. For cakes that are shelf-stable, such as packaged sponge cakes, pound cakes, or snack cakes, transportation is more flexible. These products are typically stacked in cartons and palletized to maximize space efficiency. Distribution centers receive shipments and sort cakes based on their final destinations, whether they are headed to supermarkets, convenience stores, or wholesale suppliers. In some cases, cakes are sent to intermediary facilities where additional labeling, repackaging, or regional customization takes place before reaching store shelves. Retailers follow strict inventory management practices to ensure that cakes are sold within their optimal freshness period. Supermarkets and large bakery chains use electronic tracking systems that monitor stock levels and automatically reorder cakes as needed. Cakes with shorter shelf lives are often placed in refrigerated bakery sections, while long-lasting snack cakes are displayed in standard grocery aisles. In many cases, cakes are rotated based on expiration dates to minimize waste, with older stock sold first through strategic shelving placement. For specialty cakes that require customization, such as birthday cakes or event cakes, factories often provide pre-baked cake bases that can be decorated in-store. Retail bakeries receive plain sponge layers, ready-made buttercream, and pre-mixed fillings that allow decorators to assemble and personalize cakes according to customer requests. This hybrid approach combines the efficiency of factory baking with the creative flexibility of in-store decoration. Some supermarket bakeries even utilize edible printing technology to create personalized cake designs on demand, using high-resolution printers that apply edible ink onto sheets of fondant or rice paper. The demand for factory-produced cakes continues to grow as consumers seek convenient, high-quality desserts for various occasions. Large-scale cake manufacturers constantly innovate to meet changing market preferences, introducing new flavors, textures, and dietary options. Seasonal cakes, such as holiday-themed cakes or limited edition flavors, are planned months in advance, with factories adjusting their production schedules to accommodate demand spikes. These cakes often feature special packaging, festive decorations, or unique flavor combinations that align with holiday traditions and cultural celebrations. One of the biggest trends in modern cake manufacturing is the development of healthier alternatives. Consumers are increasingly looking for reduced sugar, gluten-free, and plant-based cake options that cater to dietary restrictions and health-conscious lifestyles. Factories have adapted by reformulating traditional recipes, replacing refined sugars with natural sweeteners like stevia or monk fruit, and using alternative flours such as almond flour or coconut flour to create gluten-free variations. These formulations require precise adjustments to maintain the desired texture and taste, as the absence of gluten or sugar can affect the structural integrity of cakes. Another emerging trend is the use of functional ingredients to enhance the nutritional profile of cakes. Factories are experimenting with protein-fortified cakes, fiber-rich formulations, and probiotic-infused desserts that offer health benefits beyond traditional indulgence. Cakes with added omega-3 fatty acids, collagen, or antioxidant-rich ingredients appeal to consumers who want to enjoy sweet treats without compromising on wellness goals. Manufacturers use encapsulation technology to protect sensitive nutrients during baking, ensuring that functional ingredients remain effective even after exposure to heat. Sustainability is a growing priority in cake manufacturing, with companies striving to reduce their environmental footprint at every stage of production. Many factories have implemented waste reduction programs that repurpose cake trimmings into new products, such as cake pops, cookie bases, or cereal bar inclusions. Some manufacturers donate surplus cakes to food banks or partner with organizations that distribute baked goods to communities in need. Wastewater treatment systems, energy-efficient baking ovens, and recyclable packaging materials further contribute to sustainability efforts. The shift toward eco-friendly packaging is particularly significant, as traditional plastic cake containers contribute to global plastic waste issues. Factories are exploring biodegradable alternatives, such as plant-based plastics, compostable trays, and paper-based packaging with food-safe coatings. Some manufacturers have developed innovative packaging solutions that extend shelf life without relying on excessive plastic, using breathable film technology that regulates moisture levels to prevent staleness. Smart packaging, which includes QR codes that provide traceability information or freshness indicators that change color based on product age, is also gaining traction in the industry. The future of cake manufacturing is expected to be shaped by advancements in automation, artificial intelligence, and customization technology. AI-powered production lines are already capable of self-adjusting parameters based on real-time data, optimizing mixing, baking, and cooling processes for maximum efficiency. Machine learning algorithms analyze consumer purchasing patterns to predict demand fluctuations, allowing factories to adjust production schedules accordingly. 3D food printing is another exciting development that could revolutionize cake decoration and customization. Some companies are experimenting with 3D printed cake designs, where intricate sugar sculptures, chocolate accents, or even full cake layers are printed layer by layer. This technology opens up new possibilities for personalized cakes, allowing consumers to design unique cake structures that were previously impossible to achieve with traditional decorating techniques. Pringles are created from a specially formulated dough made primarily of dehydrated potato flakes, starches, and seasonings. The process of making Pringles in a factory involves several key stages, each meticulously designed to ensure the final product meets strict quality standards. It all begins with selecting the right raw ingredients, primarily potatoes, which serve as the foundation of the chips. However, not just any potatoes will do. Pringles require specific varieties with the right starch content to achieve the desired texture. High starch potatoes are preferred because they contribute to the crispness of the final chip and help bind the dough together during production. Once the right potatoes are sourced, they are transported in bulk to the factory, where they undergo an initial round of inspection. Before entering the processing phase, the potatoes are stored in climate-controlled environments to maintain their quality. Even small variations in temperature and humidity can affect their starch content, which in turn impacts the final texture of the chip. Workers constantly monitor these storage conditions to ensure that the potatoes remain in an optimal state before processing. When ready for use, the potatoes are moved to the preparation area, where they go through a rigorous washing process. Large industrial washers, equipped with rotating brushes and high-pressure water jets, remove dirt, debris, and any residual pesticides from the potato skins. This step is crucial, as any impurities at this stage could compromise the quality of the final product. The washing process is thorough, ensuring that only the cleanest potatoes make it to the next stage. Once cleaned, the potatoes are sent through a peeling machine, which uses either steam or mechanical abrasion to remove the skins efficiently. Steam peeling is a common method in large-scale food production, as it allows for quick and uniform removal of the skin with minimal waste. The peeled potatoes are then conveyed to slicing machines, but unlike conventional potato chips, where these slices would be fried, the goal here is to break them down into a form that can be processed into a dough. To achieve this, the sliced potatoes are sent through a pre-cooking stage, where they are partially heated to help break down their cellular structure. This step makes it easier to remove moisture later in the process. The pre-cooked potato slices are then transferred to large industrial dryers, where hot air circulates around them, slowly extracting moisture until they are fully dehydrated. What remains after this process is not whole potato slices, but thin, brittle flakes of potato. These dehydrated potato flakes serve as the primary base for Pringles and are stored in large silos within the factory. However, potato flakes alone are not enough to form the distinctive shape and texture of Pringles. Additional ingredients must be added to create the dough that will eventually be shaped into chips. When it is time to begin the production of a batch, the potato flakes are carefully measured and transferred to industrial mixing machines. Inside these massive mixers, the flakes are combined with other ingredients such as cornstarch, wheat starch, emulsifiers, and small amounts of salt and sugar. These additional ingredients help give Pringles their characteristic crunch and structure, while also ensuring that the dough is flexible enough to be shaped without crumbling. Water is then gradually added to the dry mixture, and the entire batch is kneaded until it forms a smooth, pliable dough. This step is one of the most crucial in the entire process, as the consistency of the dough determines how well the chips will hold their shape and how they will fry later in the process. Too much water and the dough will be too soft, making it difficult to handle. Too little and it will become too dry, leading to chips that may crack or break during production. The mixing process is highly automated, with computer-controlled machines ensuring that every batch has the same precise ratio of ingredients. Factories use real-time monitoring systems to adjust the moisture content and consistency of the dough as needed, ensuring uniformity across millions of chips. Any slight variation in dough quality could lead to a final product that does not meet the brand's strict standards, so maintaining precise control over this step is critical. Once the dough reaches the perfect consistency, it is ready to be shaped. However, before this can happen, the dough must be processed into thin sheets. This is accomplished using large industrial rollers, which gradually flatten the dough to an exact thickness. The thickness of the dough sheet is critical as it determines the final texture and crunch of the Pringles. If the dough is too thick, the chips will be too hard. If it is too thin, they may become fragile and brittle. The flattened dough sheet is then conveyed to a cutting station, where specially designed rotary cutters stamp out individual chip shapes. Unlike traditional potato chips, which take on random forms based on how they are sliced, Pringles are designed to be identical in size and shape. Each cutter is engineered to create the precise oval form that allows the chips to stack perfectly inside their cans. During this process, any excess dough that remains after the chips are stamped out is collected and fed back into the mixing stage. This recycling process minimizes waste and ensures that as much of the raw material as possible is used efficiently. The ability to reuse excess dough is one of the advantages of making Pringles from a formulated dough rather than whole potato slices. At this point, the chips are still in their raw, unbaked form. They have been cut into shape, but they are not yet crispy. To achieve their signature texture, they must go through the next phase of the manufacturing process, where they will be carefully molded and cooked. This is where Pringles truly begin to take on their distinctive identity. Before they can be cooked, the raw chips must be shaped into their famous curved form. This is done using a specialized conveyor system that gently places each chip into a custom mold. These molds are designed to hold the chips in a precise curve, known as a hyperbolic paraboloid, which is what gives Pringles their unique stacking ability. The shape is not just for aesthetics. It also helps distribute weight evenly when the chips are stacked in their can, preventing them from breaking easily. Once placed in the molds, the chips are conveyed toward the cooking stage, where they will be exposed to controlled heat and oil. This step is critical in achieving the crispy, golden brown texture that Pringles are known for. However, unlike traditional potato chips, which are deep fried in vats of hot oil, Pringles are cooked in a specialized method that ensures even frying while maintaining their precise shape. At this point, the chips are not yet fully cooked, nor have they been seasoned. The next phase will involve exposing them to heat and oil, followed by a careful seasoning process that gives each chip its final flavor. But before that happens, factory workers and automated quality control systems continuously monitor the process to ensure that each chip is perfectly shaped and free of defects. With the raw dough pieces now cut into their precise, uniform shapes and carefully placed into their curved molds, they are ready to undergo the critical cooking process. This step is what transforms the soft, pliable dough into the crisp, golden brown chips that Pringles are known for. Unlike traditional potato chips that are submerged in deep vats of hot oil and fried freely, Pringles undergo a much more controlled cooking method to maintain their exact shape and texture. The chips, still nestled in their curved molds, travel along a continuous conveyor belt into an industrial fryer. This fryer is designed to ensure that each chip is cooked at an exact temperature for a precise amount of time. The temperature inside the fryer is meticulously controlled, typically ranging between 300 degrees Fahrenheit and 375 degrees Fahrenheit, depending on the specific requirements of the batch being produced. The goal is to remove moisture from the chips without overcooking them, achieving the perfect crunch while preserving the uniform shape. The frying process takes only a matter of seconds, but within that short time, several crucial chemical reactions occur. The high heat causes the remaining water content inside the dough to rapidly evaporate, creating tiny air pockets that give Pringles their distinctive lightness. At the same time, the starches and sugars in the dough undergo the Maillard reaction, a chemical process that causes browning and enhances the chip's flavor by developing rich, slightly nutty, and toasted notes. Because the chips are fried in a controlled environment while sitting inside their molds, they do not curl or warp the way traditional potato chips do. Instead, they maintain their signature hyperbolic paraboloid shape, which is key to their ability to be stacked efficiently without breaking. To ensure even cooking, the oil circulates through the fryer using a sophisticated system that maintains uniform heat distribution, preventing any chip from becoming overcooked or undercooked. Once the chips have been fried to perfection, they must be quickly removed from the hot oil to prevent excessive absorption of fat, which could compromise their texture and make them overly greasy. The chips exit the fryer onto a draining conveyor, where excess oil is gently shaken off. A series of air jets then blow away any remaining oil droplets, ensuring that each chip has the right balance of crispness without being overly oily. The amount of oil that remains in the final product is carefully monitored, as even a small deviation in fat content could alter the texture and mouthfeel of the chips. After the excess oil is removed, the chips continue along the conveyor system into a specialized drying chamber. This drying stage serves a dual purpose. It helps eliminate any remaining moisture to extend the shelf life of the chips and ensures that they retain their crisp texture. If any residual moisture remains, it could lead to sogginess or even microbial growth, which would compromise the quality of the product. The drying chamber operates using a controlled flow of warm air, which gently removes any lingering humidity without exposing the chips to excessive heat. This is a crucial step because over-drying could make the chips too brittle, leading to breakage before they even reach the packaging stage. The process must strike a balance between removing moisture while preserving the ideal crunch. Now that the chips have been properly fried and dried, they still lack one essential component: flavor. While the dough contains some base seasonings, such as salt, the majority of Pringles' signature flavors are added after cooking. At this point, the chips are still relatively plain, resembling lightly salted potato crisps. To give them their final taste, they must go through the seasoning process. The chips enter a large rotating drum, which is a key part of the flavoring system. This drum functions much like a giant tumbler, gently tossing the chips to ensure that each one is evenly coated with seasoning. However, before the seasoning can be applied, the chips must be lightly misted with a fine spray of oil. This thin coating of oil acts as an adhesive, allowing the seasoning to stick uniformly to each chip without clumping. Once the oil mist has been applied, the chips move further into the drum, where a precise amount of seasoning powder is dispensed. This powder is a proprietary blend of dehydrated spices, artificial and natural flavors, and other ingredients that create the distinct taste of each Pringles variety. Whether it's the classic original, sour cream and onion, barbecue, or any of the many other flavors available around the world, each seasoning mix is carefully crafted to deliver a consistent and recognizable taste. The rotation of the drum ensures that the seasoning is distributed evenly across all chips, preventing any one chip from receiving too much or too little flavor. This is crucial because even slight inconsistencies in seasoning distribution can affect the overall eating experience. Too much seasoning on one chip could make it overpowering, while too little could make it bland. The factory's precision-engineered system ensures that every chip in a can has the same delicious taste. To confirm that the seasoning has been applied correctly, automated sensors monitor the amount of seasoning powder dispensed and the overall coating level. These sensors use advanced optical and weight measurement technologies to detect any irregularities in the seasoning process. If an issue is detected, such as an uneven application or a deviation from the standard amount of seasoning, the system can automatically adjust to correct the problem in real time. Now fully seasoned, the chips continue their journey toward the final stages of production. At this point, they must be carefully handled to prevent breakage before they are packaged. Despite their sturdy design, Pringles are still delicate enough to crack if handled too roughly, so the conveyor system is designed to gently transport them through the factory. Before reaching the packaging area, the chips pass through another quality control checkpoint. High-speed cameras and sensors inspect each chip to ensure that they meet the brand's strict standards. Any chips that are overly browned, misshapen, or broken are automatically removed from the line. These rejected chips do not go to waste. They are often ground down and repurposed as part of the raw ingredient mixture for new batches, minimizing food waste in the production process. Now, with their perfect shape, crisp texture, and flavorful coating, the chips are ready for packaging. However, the packaging process itself is an essential part of what makes Pringles so unique. Unlike traditional potato chips, which are packed into bags that allow for some degree of breakage, Pringles are carefully stacked inside rigid cylindrical cans. This design ensures that they remain intact from the moment they leave the factory to the time they are opened by consumers. As the chips approach the packaging area, specialized machines align them into precise stacks. These machines use gentle vibrations and suction mechanisms to ensure that each stack is perfectly arranged before being inserted into the canisters. The stacking process is incredibly precise. Any misalignment could cause the chips to break during transportation. At this point, the Pringles are nearly ready to be sealed and sent out for distribution, but there are still a few final steps left to complete before they can reach store shelves. The packaging must ensure freshness, provide product protection, and meet branding and labeling requirements. In the next stage, the stacked chips will be inserted into cans, sealed for freshness, and prepared for shipment. With the freshly seasoned chips perfectly stacked and aligned, the Pringles are now ready for the crucial packaging stage. This process is just as important as the manufacturing and cooking steps, as it ensures that the chips remain intact and fresh until they reach consumers. Unlike traditional potato chips, which are packed loosely in bags that allow for some level of breakage, Pringles are carefully placed into rigid cylindrical cans, a signature feature that sets them apart from other snack foods. The packaging process begins with the automatic loading of the Pringles stacks into their respective canisters. These canisters, made from a combination of cardboard and aluminum lining, are designed to provide structural support, protecting the delicate chips from breaking during transport. The cans arrive at the packaging station in a flattened state and are quickly formed into their cylindrical shape by specialized machinery. The inner lining of the cans is coated with a food-safe aluminum layer, which helps to preserve freshness by preventing exposure to moisture and air. Once the cans are fully formed, they are transported to the filling station, where the Pringles stacks are precisely inserted into them. This process requires extreme precision, as any misalignment could cause the chips to shift or break. A combination of gentle vibrations and suction mechanisms ensures that the stacks remain stable as they are guided into the canisters. If even a single chip in the stack is out of place, the entire batch may be rejected to maintain quality standards. As the filled cans move along the conveyor, they reach the sealing station, where a thin foil seal is applied to the top of each canister. This foil seal serves multiple purposes. It locks in freshness, prevents air from entering, and ensures that the chips remain crisp for an extended period. The application of the seal is a highly controlled process that uses a combination of heat and pressure to create an airtight bond between the foil and the can's rim. Automated sensors continuously monitor the sealing process, detecting any imperfections or leaks. If a faulty seal is identified, the can is removed from the production line and either reprocessed or discarded. After the foil seal is in place, a plastic lid is applied to the top of the can. This lid serves as a secondary protective barrier and allows consumers to reseal the container after opening. The lids are typically made from lightweight but durable plastic that ensures a secure fit while remaining easy to remove. Before being placed onto the cans, the lids are inspected for defects, such as warping or cracks, which could compromise the product's freshness. With the Pringles cans now fully assembled and sealed, they move toward the labeling and branding station. Here, pre-printed labels featuring the Pringles logo, flavor designation, and nutritional information are carefully wrapped around each canister. These labels are made from high-quality materials that are resistant to moisture and tearing, ensuring that they remain intact throughout the product's journey from the factory to store shelves. A combination of heat and adhesive is used to secure the labels in place, ensuring a smooth, wrinkle-free application. Once labeled, the finished cans undergo another round of quality control checks. Automated cameras and sensors scan each can to verify that the labels are correctly applied and free of defects. Any cans with misaligned or damaged labels are removed from the line and either relabeled or discarded. Additionally, random samples from each batch are taken for more detailed inspections, where factory workers check for overall product integrity, including stack alignment, sealing effectiveness, and crispness. After passing the final quality control checks, the Pringles cans are grouped together for bulk packaging. This step involves placing multiple cans into larger cardboard cartons or shrink-wrapped bundles, which make transportation and stocking more efficient. The bulk packaging process is automated, with robotic arms carefully arranging the cans into pre-formed boxes or wrapping them in durable plastic film. The goal is to maximize space efficiency while ensuring that the cans are securely held in place to prevent movement during shipping. Once the bulk packaging is complete, the cartons are sealed and labeled with batch numbers, expiration dates, and tracking information. These labels allow for easy inventory management and ensure that products can be traced back to their specific production batch if necessary. The cartons are then stacked onto pallets, which are loaded onto trucks for distribution to retailers, supermarkets, and convenience stores around the world. Before being shipped out, the finished products undergo a final inspection to verify that the correct quantities and flavors have been packed for each order. Logistics teams coordinate with distribution centers to determine the most efficient shipping routes, ensuring that Pringles reach their destinations as quickly and cost-effectively as possible. Since Pringles are a globally recognized brand, this distribution network spans multiple countries, requiring careful coordination between factories, warehouses, and retailers. Throughout this entire process, Pringles manufacturers adhere to strict hygiene and safety regulations to ensure product quality and consumer safety. Factory workers follow rigorous sanitation protocols, wearing protective gear such as gloves, hairnets, and face masks to prevent contamination. The production facilities are regularly inspected by quality assurance teams and food safety organizations to ensure compliance with industry standards. In addition to maintaining high production standards, Pringles manufacturers are constantly exploring ways to improve sustainability and reduce waste. The company has implemented initiatives to minimize environmental impact, such as optimizing energy usage in production plants, recycling excess packaging materials, and reducing food waste by repurposing rejected chips and excess dough. In some regions, Pringles packaging has been redesigned to use more eco-friendly materials, with ongoing efforts to further enhance the sustainability of the product. While the cans of Pringles are now ready to be shipped to stores, the journey does not end there. Once they arrive at retail locations, they must be carefully stocked to ensure they remain in pristine condition for customers. Store employees follow specific stocking guidelines to prevent the cans from being crushed or stacked improperly. The cylindrical shape of the canisters allows them to be displayed neatly on shelves, creating an organized and visually appealing presentation. For consumers, the convenience of Pringles packaging is one of its most attractive features. The resealable lid allows snackers to enjoy the chips at their own pace while keeping them fresh between servings. Unlike traditional chip bags that often trap excess air and lead to crushed chips, the rigid canister provides a level of protection that helps maintain the product's quality. The success of Pringles is not only due to the meticulous manufacturing process, but also to the brand's ability to continually innovate. Over the years, new flavors and limited edition varieties have been introduced to cater to different tastes and cultural preferences. Research and development teams work to create unique seasoning blends and textures that keep consumers engaged with the brand. In some cases, local flavors are developed exclusively for specific markets, adding an element of regional customization. With the fully sealed and labeled Pringles cans ready for shipment, the final step in the manufacturing process involves distribution and logistics. Once the pallets of Pringles leave the factory, they are sent to distribution centers where they are sorted based on destination. From here, they are shipped to retail locations around the world, including supermarkets, convenience stores, vending machines, and online retailers. One of the key advantages of Pringles' packaging is its durability. Unlike traditional potato chips that are shipped in large bags, prone to air compression and breakage, Pringles' rigid canisters allow for efficient stacking and transport without excessive damage. This means fewer chips are wasted due to breakage during shipping, making the product more cost-effective and reducing food waste. At the retail level, Pringles cans are often displayed in neat, vertical arrangements on shelves, taking advantage of their cylindrical shape. This design not only protects the chips, but also maximizes shelf space compared to bulky chip bags. Supermarkets and convenience stores follow specific stocking guidelines to ensure that Pringles cans remain undamaged and easily accessible to customers. Once purchased, consumers benefit from the resealable can, which keeps the chips fresh longer than traditional bags. Unlike conventional chip bags that often allow air to seep in after opening, leading to stale chips, Pringles' airtight design helps maintain their signature crunch over multiple servings. This has been a significant selling point for the brand and one of the reasons for its continued popularity. Beyond the production process, the Pringles brand continues to evolve. The company regularly develops new flavors, incorporating regional tastes and limited edition releases to cater to different markets. Flavors such as wasabi, pizza, and even dessert-inspired varieties have been introduced over the years, keeping the brand relevant and exciting for consumers. In recent years, sustainability has become a growing concern, leading to efforts to improve the recyclability of Pringles packaging. While the multi-material composition of the can presents challenges for recycling, Pringles manufacturers are exploring alternative packaging solutions that reduce environmental impact while maintaining product integrity. As technology advances, the future of Pringles manufacturing may include even greater automation, improved energy efficiency, and smarter quality control systems. artificial intelligence and machine learning could further refine production, ensuring even higher consistency in shape, flavor, and texture. Additionally, new ingredients and production techniques could be developed to create healthier or more sustainable variations of Pringles. The journey of a Lay's potato chip begins long before it reaches the factory. It starts in carefully selected farms, where high-quality potatoes are cultivated under strict agricultural standards. Lay's manufacturers work closely with farmers to ensure that only the best potato varieties are used, focusing on those with the right balance of starch and moisture. This is crucial because the composition of the potato determines how well it crisps during frying and how it absorbs seasoning. The selected varieties are chosen for their ability to produce a light, crunchy texture while maintaining the signature taste that has made Lay's a household name. The potatoes are grown in rich, fertile soil, monitored throughout the growing season to ensure optimal size, shape, and starch content. Farmers pay close attention to irrigation, pest control, and harvesting schedules to meet the brand's high standards. When the potatoes reach the perfect stage of maturity, they are harvested using specialized machinery designed to minimize bruising and damage. The harvested potatoes are loaded into large trucks and transported to Lay's production facilities, where the real transformation begins. Upon arrival at the factory, the potatoes undergo an initial inspection to check for quality, size, and any visible defects. Automated sorting machines and human inspectors work together to identify and remove any potatoes that do not meet the necessary standards. The goal is to ensure that every potato entering the production line will contribute to the consistent, high-quality chips that consumers expect. The selected potatoes are then stored in climate-controlled environments to maintain their freshness until they are ready to be processed. Before they can be turned into chips, the potatoes must be thoroughly cleaned. They pass through high-powered washing systems that remove dirt, pesticides, and any residual soil from the harvesting process. This step is crucial, as even tiny impurities could affect the taste and texture of the final product. The cleaning process uses jets of water and rotating brushes that scrub the potatoes without damaging their structure. After washing, the potatoes move along a conveyor belt toward the peeling station. Peeling is an essential step in ensuring a smooth and uniform surface for slicing. Large industrial peeling machines use abrasion or steam to remove the skin efficiently while preserving as much of the potato as possible. The peeling method used depends on the specific facility, but both techniques are designed to be fast and effective, ensuring that the potatoes retain their natural integrity. Any residual skin is removed by high-pressure water sprays before the potatoes move to the next phase of production. With the potatoes now clean and peeled, they are ready for slicing. The slicing process is one of the most critical steps in determining the texture and crispness of the final chip. The potatoes are fed into high-speed rotary slicers equipped with precision-engineered blades. These blades cut the potatoes into uniformly thin slices, ensuring that each chip cooks evenly. The thickness of the slices varies depending on the type of Lay's chip being produced, whether it's classic, wavy, or kettle cooked. The precision of the slicing process is carefully monitored, as even slight variations in thickness can affect the frying process and overall quality. Once sliced, the potato pieces undergo another quick rinse to remove excess surface starch. This helps prevent the chips from sticking together during frying and contributes to the signature crisp texture. The slices then move through an automated dewatering system, where excess moisture is removed before they enter the frying stage. Proper moisture removal is essential, as too much water content could interfere with the frying process and create inconsistencies in texture. At this point, the sliced and dried potatoes are prepared for frying. The frying process is meticulously controlled to ensure that every chip reaches the perfect level of crispness. Conveyor belts carry the slices toward massive industrial fryers filled with hot oil. The oil temperature is carefully maintained to ensure consistent cooking, and the frying time is precisely measured to achieve the ideal golden brown color. The type of oil used varies depending on the region and product line, but it is always selected for its ability to enhance the flavor and texture of the chips while meeting health and safety standards. As the potato slices enter the fryer, they begin to bubble and sizzle, their moisture rapidly evaporating as they absorb just the right amount of oil. This transformation is what gives Lay's chips their signature crunch. The frying process is closely monitored by sensors and quality control specialists, ensuring that each batch meets the company's strict standards. The duration of frying varies depending on the type of chip, but every second counts in achieving the perfect crispness. The chips continue their journey along the production line, still hot from the fryer. At this stage, they are carefully drained of excess oil using advanced drying techniques. This step is crucial, as too much residual oil could make the chips greasy, while too little could impact their mouthfeel. A fine balance must be maintained to ensure that each chip retains the light, crispy texture that Lay's is known for. With the chips now cooked to perfection, they move forward to the seasoning stage, where their flavor truly comes to life. Lay's offers a wide variety of flavors, from the classic lightly salted to bold, complex seasonings that cater to different tastes and preferences. Each flavor blend is created using a combination of spices, herbs, and other ingredients that have been meticulously tested for balance and intensity. The seasoning process is highly specialized to ensure even distribution, guaranteeing that every chip is coated with the perfect amount of flavor. Before seasoning is applied, the chips pass through a gentle tumbling system that helps prepare them for even coating. This ensures that every chip has an optimal surface for seasoning adherence. A light mist of oil may be added at this stage to help the seasoning stick, ensuring that every bite delivers the intended flavor experience. The seasoning is then evenly sprinkled over the chips using automated dispensers that precisely measure the amount applied. Quality control specialists continuously test and monitor the seasoning levels, ensuring that each batch is consistent. Lay's has developed advanced flavoring systems that use real-time feedback to adjust the seasoning application as needed. This ensures that no chip is under-seasoned or over-seasoned, preserving the product's signature taste. Once the chips have been seasoned to perfection, they continue moving along the production line toward the next stage of the process. The chips must be handled carefully to prevent breakage and ensure they retain their structure as they progress through the factory. The journey is far from over, with several more key steps left before they are ready for packaging and distribution. As the freshly seasoned chips continue moving through the production line, they enter one of the most critical stages of the entire process: quality control. Lay's has built its reputation on delivering chips that are consistent in taste, texture, and appearance. And this is only possible through rigorous inspections at multiple points along the manufacturing process. Each chip must meet exacting standards before it is deemed fit for packaging, so quality control systems are an integral part of the factory's operation. The first stage of quality control involves high-speed cameras and sensors that scan the chips as they pass along the conveyor belt. These cameras are equipped with advanced imaging technology that detects any chips that are misshapen, burnt, undercooked, or broken. If a chip does not meet the specified criteria, it is automatically removed from the production line using precision air jets that quickly and efficiently separate defective chips from the rest. This ensures that only chips of uniform shape, size, and color continue on their journey. Alongside the automated quality control systems, trained inspectors conduct manual checks at various points in the production process. These specialists sample chips from every batch, testing for crunchiness, oil content, seasoning distribution, and overall flavor consistency. Taste tests are regularly performed to ensure that every chip has the signature Lay's flavor profile. If an inconsistency is detected, adjustments can be made immediately to the frying temperature, seasoning application, or oil levels to correct the issue before it affects a large quantity of product. While the chips are still warm, they move along the conveyor belt toward the cooling system. The cooling stage is essential because the chips must be brought down to a stable temperature before they can be packaged. If the chips were packed while still warm, condensation could form inside the packaging, leading to sogginess or loss of crispness. To prevent this, the chips pass through cooling tunnels where controlled air circulation gradually reduces their temperature. This step ensures that when the chips reach the packaging stage, they maintain their light, crunchy texture. Once cooled, the chips approach another crucial phase, sorting and weighing. The production line is equipped with highly sensitive scales that measure precise portions of chips. These automated weighing systems are programmed to dispense an exact amount of chips into each bag, ensuring consistency across all packages. The portioning must be extremely precise to meet regulatory weight standards and ensure that customers receive the correct amount of product. Any deviations in weight trigger an automatic adjustment in the dispensing system. After portioning, the chips are directed into the bagging machines, where specially designed Lay's packaging material awaits them. The bags are made from multi-layered, high-barrier film that helps protect the chips from moisture, light, and oxygen, 3 factors that can negatively impact their freshness and taste. The packaging is specifically designed to extend shelf life while preserving the signature crunch and flavor. As the chips drop into the open bags, a stream of nitrogen gas is injected into each bag before sealing. This process, known as nitrogen flushing, serves a crucial purpose. By replacing the oxygen inside the bag with nitrogen, the factory prevents oxidation, which can cause the chips to become stale over time. The nitrogen also helps create a cushioning effect inside the bag, preventing the chips from breaking during transportation and handling. The sealed bags are then heat sealed using precision machinery that ensures an airtight closure. Once sealed, the freshly packed bags of Lay's chips move along the conveyor to the final quality control checkpoint. Here, inspectors verify that the bags are sealed properly, that they contain the correct weight, and that there are no issues with the packaging material. Automated sensors scan the bags for any irregularities, such as improper sealing or printing errors on the labels. If any issues are found, the defective bags are removed from the line before they reach distribution. At this point, the bags are ready for bulk packaging. Large robotic arms carefully arrange the individual chip bags into larger cartons or cases, which are then sealed and labeled for shipment. The cases are stacked onto pallets in an optimized configuration to maximize space efficiency in shipping trucks and storage facilities. The pallets are then loaded onto trucks and transported to Lay's distribution centers, where they are sorted based on their destination. While the chips are being prepared for distribution, data is continuously being collected from the production line to track performance and efficiency. Advanced factory management systems monitor every aspect of the manufacturing process, from the amount of raw materials used to the speed of production. This data allows production teams to identify trends, detect potential inefficiencies, and make real-time adjustments to improve overall operations. Lay's chips are manufactured in multiple facilities worldwide, ensuring that they can reach markets across different regions quickly and efficiently. Each factory follows strict food safety guidelines and adheres to regional regulations to maintain high product standards. The factories are designed to operate at peak efficiency while maintaining rigorous hygiene and cleanliness protocols. Workers in the facility adhere to strict sanitation procedures, including wearing protective clothing, gloves, and hairnets to prevent contamination. Even though the chips have left the factory and are on their way to retailers, the process does not stop there. Lay's has extensive logistics networks that ensure a steady supply of chips to stores and vending machines worldwide. Once the shipments arrive at retail locations, store employees follow best practices for stocking the product, making sure that older batches are sold first while newer shipments are placed behind them to maintain freshness. Lay's packaging is also designed for high visibility on store shelves, making it easy for customers to recognize their favorite flavors at a glance. The branding and design of the bags play a crucial role in marketing, with vibrant colors and flavor indicators clearly displayed. The bags are designed not only to protect the chips, but also to appeal to consumers through enticing imagery and messaging that highlights the quality and taste of the product. The popularity of Lay's chips has led to ongoing innovation in flavors, textures, and packaging options. Consumer feedback plays a major role in shaping new product developments, with research and development teams continuously testing new seasonings and chip varieties. Limited edition flavors and region-specific varieties allow Lay's to cater to different preferences across global markets. This constant evolution keeps the brand fresh and exciting for snack lovers worldwide. With the perfectly seasoned and packaged Lay's chips now prepared for distribution, the process continues beyond the factory walls. While the manufacturing process itself is a highly controlled and precise operation, what happens after the chips leave the factory is just as critical to ensuring that consumers receive a fresh, high-quality product. The logistics and supply chain management of Lay's chips play a crucial role in maintaining their availability across grocery stores, vending machines, and online retailers worldwide. Once the sealed bags are loaded into cartons, they are arranged onto pallets with extreme precision to maximize storage space and minimize movement during transportation. Each carton is labeled with important tracking information, including batch numbers, production dates, and expiration dates, allowing for full traceability. This ensures that if any quality issues arise, specific batches can be quickly identified and recalled if necessary. The pallets are then wrapped securely to prevent shifting during shipment, ensuring that the chips inside remain intact. From the factory, these pallets are transported to Lay's regional distribution centers, where they are sorted based on their intended destination. These distribution hubs act as the central points from which shipments are sent out to retail locations. Temperature and humidity levels inside the warehouses are carefully maintained to ensure that the chips do not absorb excess moisture, which could compromise their crisp texture. At this stage, automated inventory management systems help keep track of shipments, ensuring that stores receive the correct quantities and flavors based on regional demand. As the chips are shipped out to grocery stores, convenience stores, gas stations, and other retail locations, the logistics team continuously monitors their movement. The goal is to minimize the time it takes for a freshly produced bag of chips to reach the shelves, preserving the crunch and flavor that customers expect. Lay's supply chain is designed for efficiency, with trucks following optimized routes to deliver products as quickly as possible. In some cases, chips that are produced in the morning can be on store shelves by the afternoon in nearby regions. At retail locations, store employees are trained to handle Lay's chips carefully during stocking. The lightweight nature of the packaging means that the bags can be susceptible to compression if not stacked correctly. Retailers follow strict guidelines to ensure that chips are displayed properly, with newer shipments placed behind older stock to maintain freshness. In vending machines, the placement of Lay's chips is also optimized to prevent excessive movement that could lead to breakage. The careful handling of the product at every stage is what ensures that customers receive whole, unbroken chips when they open a bag. The journey of Lay's chips does not stop at store shelves. Consumer feedback plays a vital role in shaping future production decisions. Lay's has dedicated teams that analyze purchasing trends, customer reviews, and market demands to determine which flavors and varieties are most popular. This data influences everything from production volume to regional flavor innovations, ensuring that Lay's continues to evolve with consumer preferences. In some cases, limited edition flavors are introduced based on feedback, with certain varieties becoming permanent offerings if they prove successful. As technology advances, Lay's continues to refine its production methods to improve efficiency, reduce waste, and enhance sustainability. One of the major challenges in large-scale snack production is minimizing the environmental impact of operations. To address this, Lay's has implemented initiatives to optimize energy usage in factories, improve water conservation during potato processing, and explore more sustainable packaging solutions. One of the key sustainability efforts involves reducing food waste during production. While some defective chips are removed during quality control, they are not simply discarded. Instead, these chips are often repurposed as animal feed or converted into biofuel, ensuring that as little as possible goes to waste. Additionally, potato scraps from the peeling and slicing process are collected and used for other food products or composting. The use of sustainable farming practices is also a priority for Lay's suppliers. Many of the farms that provide potatoes for Lay's have adopted eco-friendly techniques such as crop rotation, reduced pesticide usage, and precision irrigation to minimize water consumption. By working closely with farmers, Lay's ensures that its supply chain remains both environmentally responsible and efficient. Packaging innovation is another area of focus for Lay's as it looks for ways to make its chip bags more eco-friendly. Traditional chip packaging is made from multi-layered plastic film, which is designed to protect the chips from moisture and air exposure. However, the complex nature of this material makes it difficult to recycle. Lay's has been researching alternative packaging solutions that maintain freshness while reducing plastic waste. Some markets have already seen the introduction of biodegradable or recyclable chip bags, with further developments expected in the future. Automation and artificial intelligence are also playing an increasing role in Lay's production process. Advanced AI-driven quality control systems are being used to detect imperfections with greater accuracy than ever before. These systems can analyze thousands of chips per second, ensuring that every batch meets the highest standards. Additionally, robotic automation is improving efficiency in packaging and palletizing, allowing for faster and more precise handling of products. Beyond production, Lay's continues to engage with consumers through marketing, advertising, and promotions. The brand regularly collaborates with chefs, influencers, and food scientists to introduce new flavors and snack innovations. Limited edition seasonal flavors, cross-cultural fusion varieties, and unique textures like extra crispy or extra flavored chips keep the product line dynamic and exciting for customers. One of the most intriguing aspects of Lay's chips is how different regions have their own exclusive flavors, reflecting the local tastes and culinary preferences of different cultures. In Asia, flavors such as seaweed and spicy hot pot are popular, while in North America, barbecue and sour cream and onion remain among the best sellers. Europe has its own set of unique offerings, including flavors inspired by traditional cheeses and herbs. The ability to adapt to different markets while maintaining the core essence of Lay's chips is what has helped the brand maintain its global appeal. At its core, the production of Lay's chips is a blend of science, technology, and tradition. The balance between maintaining the classic quality that customers expect while continuously innovating is what keeps Lay's at the forefront of the snack industry. From the careful selection of potatoes to the high-speed frying process, precise seasoning application, and advanced packaging techniques, every step is optimized to ensure consistency, flavor, and crunch in every bite. The cycle of chip production never truly stops. Even as one batch is being transported to stores, another is already being prepared in the factory. The efficiency of the Lay's production process ensures that there is always a fresh supply of chips available for consumers. The combination of high-tech manufacturing, sustainability initiatives, and a deep understanding of consumer preferences keeps Lay's chips at the top of the snack food market, continuously evolving to meet the changing tastes and expectations of snack lovers around the world. It all begins with the selection and preparation of ingredients. The core elements of Fanta include water, sweeteners, fruit flavorings, citric acid for tartness, preservatives to maintain shelf life, and carbon dioxide to give the drink its signature fizziness. However, each flavor, such as orange, grape, pineapple, or strawberry, requires a different combination of fruit extracts, natural or artificial colorings, and acidity regulators. These ingredients must meet strict quality and safety standards before they can be used in production. Water, being the main component of Fanta, is the first ingredient to be processed. The quality of the water used in soft drinks plays a crucial role in the final product's taste, clarity, and stability. Factories receive water from local sources, but before it can be used, it must go through an extensive purification process. This process begins with coarse filtration, where large particles, sediments, and debris are removed. The water is then passed through activated carbon filters to eliminate organic compounds, chlorine, and any undesirable odors or tastes. Finally, a reverse osmosis system is used to ensure the highest level of purity. This stage is critical because even the slightest variation in water quality can alter the flavor profile of Fanta. While the water undergoes purification, the syrup production process begins. This is where Fanta's distinctive flavor is created. In large mixing tanks, the essential ingredients are blended to form a concentrated syrup. Each flavor variation has its own unique formulation, requiring precise measurements of fruit extracts, sweeteners, and acids. Citric acid is commonly used to provide a tartness that enhances the fruity taste, while different natural and artificial flavorings are combined to create the signature taste of each Fanta variety. Sweeteners play an essential role in balancing the overall flavor. Depending on the region, the factory may use high fructose corn syrup, cane sugar, or alternative sweeteners such as aspartame for sugar-free versions. The exact ratio of sweetener to other ingredients must be meticulously controlled, as too much or too little can dramatically affect the drink's taste and mouthfeel. Once the syrup is mixed, it undergoes a process called homogenization. This ensures that all the ingredients are evenly dispersed and that no separation occurs during storage. The syrup is then transferred to large storage tanks, where it is kept under strictly controlled conditions before being combined with purified water. These tanks are equipped with continuous mixing systems to prevent any settling or inconsistencies in the formula. At this point, the production process moves to the batching stage, where the syrup is mixed with purified water in exact proportions. The goal here is to dilute the concentrated syrup to the precise flavor concentration required for Fanta. The ratio of syrup to water must be carefully maintained, as even a small deviation could result in a drink that is too strong or too weak in flavor. This blending process takes place in specially designed tanks, where the mixture is continuously stirred to ensure uniformity. While the flavor base is being prepared, another critical step is underway: deaeration. Deaeration is the process of removing excess oxygen from the liquid before carbonation takes place. If too much oxygen remains in the mixture, it can affect the beverage's stability, leading to unwanted changes in taste and shelf life. The deaeration process occurs under vacuum conditions, pulling out any dissolved air and preparing the liquid for the next crucial phase, carbonation. Carbonation is what gives Fanta its characteristic fizz. This step involves the careful infusion of carbon dioxide gas into the liquid under controlled pressure and temperature. The conditions must be just right, as the solubility of CO2 depends on temperature and pressure levels. If the carbonation process is not precise, the drink may become too flat or overly fizzy, both of which can negatively impact the consumer experience. The level of carbonation is carefully calibrated for each variety of Fanta, as some flavors require a different mouthfeel to enhance their particular fruit notes. Meanwhile, quality control tests are performed at every stage of production to ensure that the beverage meets strict consistency and safety standards. Samples from each batch are taken to an on-site laboratory where they are analyzed for acidity levels, sugar content, and overall taste. Highly trained technicians conduct these tests using specialized equipment to confirm that every batch meets the exact specifications required. If any deviation is detected, adjustments are made immediately before the product moves further along the production line. At this stage, the Fanta mixture is nearly complete, but it still has to be monitored for consistency before it can proceed to bottling. The temperature of the liquid must be kept within an optimal range to ensure the carbonation remains stable. If the temperature fluctuates too much, carbon dioxide may escape, resulting in a less fizzy drink. Advanced monitoring systems are used to track and adjust these conditions in real time, ensuring that the beverage is ready for the next stage of production. While the main beverage formulation is being perfected, the factory is simultaneously preparing the bottles and cans that will hold the finished product. Modern beverage production facilities use an advanced system for bottle manufacturing and preparation. For plastic bottles, the process begins with small PT preforms that are heated and expanded into their final shape using high-pressure air in a process called blow molding. This allows the factory to produce lightweight, durable bottles on-site, reducing the need for external suppliers and increasing efficiency. Glass bottles and aluminum cans follow a different preparation process. They are delivered to the factory pre-made and must undergo thorough cleaning and sterilization before being used. Each bottle or can is subjected to a high-pressure rinse with purified water and a sanitizing solution to remove any potential contaminants. Strict hygiene protocols ensure that every container is completely sterile before it reaches the filling stage. At this point in the production process, everything is coming together. The beverage is fully mixed, carbonated, and quality tested, while the bottles and cans are ready for filling. However, there are still multiple steps left to ensure that every bottle of Fanta meets the highest production standards. The next stage will involve high-speed filling, sealing, labeling, and additional quality control checks before the finished product is packaged and prepared for distribution. As the production line continues, the coordination of multiple systems working in perfect harmony becomes apparent. Every ingredient, machine, and quality control checkpoint plays a role in making sure that Fanta reaches consumers in the best possible condition. This highly organized process reflects the complexity behind what may seem like a simple bottle of fruity, fizzy refreshment. With the Fanta mixture fully prepared, carbonated, and quality tested, the production process moves toward the next major stage, the filling and bottling process. This part of manufacturing is one of the most crucial, as it requires absolute precision to ensure that every bottle or can is filled to the correct level, sealed properly, and protected from any external contamination. The entire operation is designed for efficiency, with high-speed machinery handling thousands of units per hour. Before the filling process can begin, the bottles and cans must be ready to receive the beverage. If plastic bottles are used, they have already gone through the blow molding process, where PET preforms are heated and expanded into their final shape. These bottles are lightweight, durable, and designed to withstand the pressure of carbonation. Glass bottles, on the other hand, arrive at the factory pre-made and must go through a thorough cleaning and sterilization process before being used. Similarly, aluminum cans are delivered in bulk and are also washed and sanitized to ensure absolute cleanliness. The sterilization process for bottles and cans is highly controlled. Each container is subjected to a series of high-pressure water jets and steam treatments, removing any potential contaminants that could affect the final product. In addition to physical cleaning, a chemical sanitization step is included, ensuring that no bacteria, dust, or residue remains inside the containers. Any bottle or can that fails to pass the cleanliness check is removed from the line and sent for reprocessing or disposal. Once the bottles and cans are verified as clean and sterile, they move along the production line toward the filling machines. These machines are designed to dispense the Fanta mixture with extreme precision, ensuring that each container receives exactly the right amount of liquid. The filling process must also take into account the carbonation level of the beverage. Since Fanta is a carbonated drink, the liquid is dispensed in a way that prevents excessive foaming and preserves the right amount of carbon dioxide. This is achieved through a pressurized filling system that maintains the carbonation inside the liquid as it is transferred into the bottles and cans. Different types of filling systems are used depending on the packaging format. For plastic bottles, a gravity filling system is often used, allowing the liquid to flow smoothly into the bottles while maintaining precise volume control. For aluminum cans, a counter-pressure filling system is more common, as it helps retain carbonation and prevent spillage. Regardless of the method, the goal is to ensure that each unit is filled with the same exact volume of Fanta while maintaining its fizziness and freshness. Once the bottles and cans are filled, they move to the capping and sealing station. This step must be completed almost instantly after filling to prevent any loss of carbonation. Plastic bottles are sealed with screw-on caps, which are applied using high-speed capping machines that tightly secure each cap onto the bottle's neck. These caps are designed to hold in the pressure from carbonation, ensuring that the drink remains fizzy until opened by the consumer. For glass bottles, a crimped metal cap, often called a crown cap, is used. These caps are pressed onto the bottle opening with a strong mechanical force, creating an airtight seal. The use of crown caps ensures that the carbonation remains intact, preventing any loss of fizz over time. Meanwhile, aluminum cans are sealed with pull-tab lids, which are crimped onto the can opening to create a pressurized seal. The precision required for this step is immense, as even the slightest sealing error can lead to leaks or loss of carbonation. With the bottles and cans now sealed, the next stage in the production process is labeling and batch coding. Labels are an essential part of Fanta's branding, providing consumers with product information, flavor identification, and branding visuals. The labeling process is highly automated, with machines applying labels to bottles at high speeds. These labels must be aligned perfectly, as any misalignment could make the product appear unprofessional or difficult to identify on store shelves. In addition to labels, each bottle and can receives a batch code, typically printed using a laser or inkjet printer. This code includes details such as the production date, expiration date, and batch number. The purpose of this coding is to allow for easy traceability in case of any quality issues. If a batch is found to have any defects, the factory can quickly identify and recall only the affected products, minimizing waste and ensuring consumer safety. Now that the filled and sealed Fanta bottles and cans have been labeled and coded, they move on to the final inspection phase. This is one of the most important parts of the entire manufacturing process, as it ensures that every single unit meets strict quality control standards. Advanced inspection systems are used to detect any defects in the bottles, cans, or caps. High-speed cameras and laser sensors scan each product to check for issues such as improper sealing, incorrect fill levels, label misalignment, or damaged packaging. Any defective products that do not meet quality standards are automatically removed from the production line. This ensures that only perfect, high-quality Fanta reaches consumers. The rejected bottles and cans are sent to a separate area for recycling or disposal, depending on the nature of the defect. If the issue is a minor one, such as a misaligned label, the product may be corrected and reintroduced to the production line. Once the final inspection is complete, the ready-to-ship bottles and cans are transported to the packaging area. This is where they are grouped into multi-packs or placed in cartons for easier distribution. The packaging process is fully automated, with robotic arms handling the placement of bottles into trays, shrink-wrapping multi-packs, and stacking cases onto pallets. The type of packaging used depends on the market. In some regions, Fanta is commonly sold in large multi-packs wrapped in plastic film, while in others, cardboard cartons are used to hold smaller packs together. Sustainability plays a significant role in Fanta's packaging process. Many of the plastic bottles used are made from recycled PET, which reduces plastic waste and environmental impact. Factories are continuously working to reduce plastic usage by making bottles lighter while maintaining their durability. Similarly, paper-based packaging materials are sourced from sustainable forests to ensure that the environmental footprint of production remains as low as possible. Once packaged, the finished products are transported to storage areas within the factory. These areas are climate controlled to maintain the freshness and quality of the beverages before they are shipped out to retailers. The inventory system used in the warehouse tracks every pallet of Fanta, ensuring that stock is rotated properly to maintain freshness. Products are organised based on their production dates, with older stock being distributed first to ensure that consumers always receive the freshest possible drinks.